635 light years away from Earth, there's a world covered in liquid ocean. A world where you wouldn't die a horrible death. Probably. Welcome to Kepler 22b.
Hey y'all, I've got an exciting mission to land on and explore a planet that could be Earth 2.0. What if guy got tired of sending me to die in the solar system, so this time I'm traveling to an exoplanet where I might actually have a chance to survive. Exoplanets are like planets in our solar system, except they orbit different stars. They're cool, but there's just one problem. Exoplanets are really far away. So your solar system is this tiny little neighborhood with planets and moons orbiting around a sun in its center. And potentially, light years away, there are billions of other tiny little neighborhoods left to be explored. Now, you might have heard of the exoplanet that I'm going to. It's called Kepler 22b. It's not that far. Okay, only 635 light years. I'll be there in no time.
Even with advanced propulsion technology, a spacecraft traveling at 20% of the speed of light would require 3,175 Earth years to reach Kepler 22b.
Buzzkill. Well, luckily, I'm at a spaceport, and they have this, warp drive technology. So I'll be there in a jiff.
The warp drive technology allows a spaceship to travel faster than light by bending space-time. The warp drive creates a bubble around the ship, moving it through space safely, 99.7% of the time.
Yeah, Rico, technobabble, blah, blah, blah. Never tell me the odds, kid. Let's do this.
You know, this year has been pretty hectic for me here on the channel, but instead of just chugging coffee to work on the next video, I've been taking some ultra recharging naps. This is where Manta Sleep comes in. They make the world's best sleep masks and accessories. I've been using the Manta Sound sleep mask, and it's completely transformed the way I nap. Not only does it cover my eyes, allowing me to sleep anywhere, but it also has Bluetooth headphones built right in. So maybe I want to listen to the sounds of the rainforest, or maybe even listen to some relaxing what if YouTube videos as I sleep. And this isn't just about catching some extra Z's at the office. No, better sleep means a better you. It's scientifically proven that our bodies are wired to nap. So instead of trying to push through my afternoon slump with a coffee or an energy drink, I've been taking naps. It's given me the energy and focus I need to get through the day. Kind of like hitting the reset button on my body, sort of giving me a second morning. So if you're ready to optimize your energy, fuel your creativity, and take back your day, well, visit mantasleep.com to learn more. And use my code WHATIF to get 10% off your order.
Well, hello, Kepler.
The Kepler 22 star system is a lot simpler than our solar system. It's only got one exoplanet in it. But this exoplanet, named Kepler 22b, is intriguing. It orbits within the star's habitable zone. And that means one important thing.
Alien civilization.
Water. It means water.
Oh.
Whenever a planet is in the habitable zone of its star, it means that the temperature is warm enough for water to remain in a liquid state, instead of evaporating, like it would, say, on Venus, or freezing like it would on Mars. And the Kepler 22 star is almost exactly like our Sun. It's a slightly smaller G-type star, which means it has a surface temperature of around 5,500 Kelvin. That's 5,200 degrees Celsius. Not too bad for a distant star system, except one thing. This exoplanet, Kepler 22b, is a lot bigger than Earth.
I don't see how that's a problem. It's just more surface to love. I mean, sure, it might have stronger gravity or, like, earthquakes. Kepler quakes? But, like, Earth has earthquakes too, and it's doing just fine.
The larger size of the exoplanet might indicate the presence of a thick atmosphere, leading to high surface pressure. This could result in water existing in a supercritical state, neither a true liquid nor gas, making it less suitable for life as we know it.
It's true, scientists think Kepler-22b might be covered with a liquid ocean, but they can't be sure what that ocean is like. Your mission is to land down there and test the water and the atmosphere.
Yeah, I was just gonna, land. So, here goes the landing sequence. Whew. It's been almost an hour, and all I see is water. Water! Everywhere water! I think I can land here. Seriously, Kepler, you are one disappointing exoplanet. Give up, Rico. Wake me up if you see any land.
My sensors read land right below us. You are cleared for landing.
Seriously? I can't even take a nap. Okay, let's land. Whoa, this atmosphere is thick! Rico, give me some stats on this planet.
Kepler-22b is a super-Earth, 2.1 times larger and 9.1 times more massive than Earth. It has an orbital period of 289.9 Earth days. It also has water.
Oh, does it? Does it have water? Oh God, thank you so much, Rico. You know, the atmosphere actually kind of looks breathable too. You know, this started out super annoying, but this is actually kind of cool.
Analyzing Kepler-22b atmosphere.
You do that. I'm gonna go see what's out there. Interesting. That feels nice. I could go skinny dipping in here.
That would violate YouTube's terms of service.
Not if it's a music video, technically. Ooh, Rico, what's the temperature out here? I'm starting to feel like some warm bread in a toaster. Toasty.
The equilibrium temperature on Kepler-22b is estimated to be 22 degrees Celsius. However, my sensors pick up a much higher surface temperature.
If Kepler-22b has a thick atmosphere, it would cover the planet like a blanket, heating it up and turning it into an exoplanetary Venus. If the temperature becomes too high, all the water will turn into vapor and Kepler-22b will stop being a habitable world. On the other hand, if Kepler has no atmosphere, well, it might become a frozen world. It would be incredibly cold at night because with no atmosphere, there would be nothing to retain the heat from the day.
That sounds just like Mercury. Not my favorite planet. My favorite planet is Uranus. Kepler-22b, yeah, it seems okay. It's a little tough to walk here.
The surface gravity on Kepler-22b is approximately 2.07 times the gravity of Earth.
Yeah, thanks. I noticed that one, Rico. Hey, have you analyzed the atmosphere yet?
Analysis in process.
Oh, so the answer was no. You're still okay.
The thick atmosphere of Kepler 22b likely contains high levels of hydrogen and helium. Those are two gases that are common on larger planets. But if there isn't any oxygen in the atmosphere, you wouldn't be able to breathe. What you should also worry about is the water. It could be acidic or contaminated with toxic elements like heavy metals. Exposure to the body could prove fatal.
Great. So, there's water on Kepler 22b, not that I can drink it, and the atmosphere's in place, and the temperature's all right. What am I missing? Where's all the life?
If life exists on Kepler, it might be microbial. You wouldn't be able to see it without special equipment.
Did you hear that?
My scans are not picking up any life forms.
I gotta check this out. I just need a break first. All this walking around makes me sore. I gotta sit down for a second. I just need to catch my breath.
The atmosphere analysis is not complete.
It's okay. 1 second's not gonna kill me.
Analysis complete.
Something's wrong.
The atmosphere caused your lungs to collapse as a result of barotrauma.
Okay. Thank you.
It looks like the sudden increase in pressure forced the air in Chase's lungs to compress and rupture. One internal organ failure after another, and just like that, he's gone. But don't worry, he'll show up for his next adventure. This is the Titanoboa, one of the largest and deadliest snakes to ever exist. It went extinct 55 million years ago, but what if that never happened? What if the Titanoboa just kept evolving and was alive today? What special traits would this deadly creature have? And how big could it get? This is What If, and here's what would happen if the Titanoboa never stopped evolving. Okay, before we look at the modern day Titanoboa, we need to go back. 60 million years ago, the Titanoboa lived in the tropical waters of South America, arriving on the scene after the dinosaurs went extinct. It was a major predator of its time. This snake was unimaginably large. It had a girth of about 1 meter. That means if it were slithering on the ground toward you, it would come up to your waist. It was 14 to 15 meters long, and it weighed over 1,000 kilograms. Luckily, the Titanoboa wasn't venomous, but don't let that trick you into believing it was safe. It had a different way of killing its victims, by squeezing the life out of them. Literally, by wrapping itself around your body or squeezing your windpipe, and then swallowing you whole. And if you tried to slip out, you'd be met with rows of sharp little teeth that would dig into you. But you could see this creature coming, right? No, not a chance. The Titanoboa was the perfect color, a color that allowed it to camouflage itself in its swampy environment. It would sit and wait for the perfect moment to strike. It feasted mainly on fish, turtles, and crocodiles. So, if the Titanoboa was so dominant, what finally made it go extinct? Well, it had to do with a massive change in climate. But to understand this, let's first dive into what made the Titanoboa such a dominant creature, and then how it suddenly went extinct. Paleocene, 66 million years ago to 56 million years ago. Titanoboas emerged after the apex predator niche was left empty by the extinction of the dinosaurs. They thrived in hot and humid environments. Lucky for them, that's what Earth happened to be like 60 million years ago. The average temperature was around 24-25 degrees Celsius. Now, we love that temperature in the summer, but Imagine if it were that way the whole year. Instead of ice caps, the poles were covered with forests, and instead of polar bears, there were alligators roaming around. Just like today, a planet even a few degrees hotter is very unpleasant for human beings, so it's a good thing we weren't around at that time. But there's a set of animals that thrive in the heat, cold-blooded ones. Our Titanoboa was cold-blooded, so it loved warm weather. Unlike warm-blooded creatures, cold-blooded animals aren't able to regulate their own body temperature. They use heat from the environment to warm up their bodies and kick their metabolism into a higher gear. So a warmer Earth was perfect for the Titanoboa. It had a supply of external energy to keep its body warm, hunt without mercy, and become one of the largest predators ever. But then the Titanoboa went extinct. Why? Well, a lot of changes were happening at this time. The Earth experienced two very different climate shifts. First, it became very hot, and then it cooled down. With our current evidence, it's not clear if the Titanoboa became extinct during the heat spike or during the cooling phase. So let's look at each change and try and figure out what might have happened. The heat spike event, 56 million years ago. It was 56 million years ago that Earth suddenly got super hot. The official name for this heat spike is the Paleocene-Eocene Thermal Maximum, or PETM for short. Massive amounts of carbon dioxide entered the atmosphere, raising the temperature by up to 8 degrees Celsius. The seas became really hot. In the tropics, it was like a warm bathtub with temperatures around 38 degrees Celsius. There was a mass extinction of creatures in the deep sea. In particular, many single-celled creatures called forams died out. Now, for the Titanoboa, this may have resulted in two different outcomes. It's possible that this giant snake thrived in hot water and became larger. Even if some fish were dying, other reptiles like turtles and crocodiles could have also grown big with the heat and became a great food source for the Titanoboa. So in this scenario, our Titanoboa just gets bigger and badder during the heat spike. But there's another possibility. Maybe the Titanoboa went extinct due to the warmer temperatures. Because the heat spike was so sudden, oceans absorbing carbon dioxide would have become more acidic. Many fish may have died in that acidic warm water, which would have meant fewer fish for the Titanoboa to eat. Now, if this were the case, the Titanoboa would have needed to adapt to survive. What evolutionary change could have helped it survive this heat spike? Well, if the tropical waters were too hot and acidic to live in, moving onto land would have been Titanoboa's best bet. Yeah, switching from a mostly pescatarian diet to being a meat eater. Now, as Earth became warmer, something interesting was happening. Above the waterline, the land was exploding with different types of mammals. Camels, horses, pigs, goats, and giraffes all evolved when Earth was a giant sauna. So, if Titanoboa moved from water to land, it would have found some new foods to keep it going. But because of its large size, living on land would have been difficult. So our Titanoboa would need a different kind of adaptation to get through this temperature spike. The giant snake is going to get some stronger swimming muscles and swim up to the poles, because now the poles have warmed up so much that they're tropical. The ice melted into water and the polar seas were full of crocodiles. The perfect lunch for a hungry Titanoboa. Eocene and Oleocene, 56 million years ago to 23 million years ago. Okay, after 200,000 years, the heat spike was finally over and temperatures went back to what they were before. But another major shift in climate is on the way, a cooling. Around 50 million years ago, temperatures began dropping in a long-term cooling trend that lasted until the dawn of civilization. The once lush forests at the poles are now becoming ice caps. This was bad news for the Titanoboa. The cooler climate didn't suit this cold-blooded snake. It could no longer get the heat it needed from the environment to be able to power itself. It's possible that this led to the Titanoboa's extinction about 55 million years ago. In order to survive, it would have had to evolve in a different and totally unexpected way. In our hypothetical scenario, the Titanoboa becomes warm-blooded. Maybe you're thinking, well, can a cold-blooded animal really become warm-blooded? Well, how is that even possible? Well, it's true that if we look at snakes, we don't see any examples of them being warm-blooded, but there is another category of cold-blooded creatures that have some warm-blooded exceptions. Fish. While the majority of fish are cold-blooded, about 0.1% are partially or fully warm-blooded. For instance, the moonfish is warm-blooded. Bluefin tuna, white sharks, and salmon sharks are kind of both. They use a special mechanism to raise their body temperature called vascular countercurrent heat exchange. Let me show you how it works. Let's use a shark as an example. Now, the muscles they use to swim generate heat, which heats blood in the veins. The arteries bring cold, oxygenated blood from the gills to the shark's muscles and organs. This cold blood picks up the heat from blood in the veins, which then raises the shark's internal temperature. But in the Titanoboa's case, there are no gills involved. It breathes in through its nostrils and has lungs to supply it with oxygen. But we can make it warm-blooded like the shark by having cold blood pumped in through the arteries, which then pick up the heat from the warm blood in the veins. This single evolutionary transformation would allow the Titanoboa to survive the mass cooling. Let's see what happens next. Miocene, 23 million years ago to 5 million years ago. During the Miocene epoch that followed, Earth began to warm a little, followed again by a period of cooling. The climate became drier and vegetation was more coarse. Rhinos were dominant in North America. Many species of horses evolved, as did a variety of camels. Also, a saber-toothed cat-like creature called the Nimravid roamed around. Could the Titanoboa have adapted in new and different ways to spawn a line of desert Titanoboas? Yeah, I know I said that living on land would be tough for such a massive creature, but maybe there's an evolutionary path to make this possible. To camouflage in the desert, it would need to adapt a new color scheme, a light sandy color. And its next most important adaptation? Strong muscles to burrow into desert soil and live underground during the day, both to conserve energy and to hunt under the cover of darkness. Now, to protect against water loss through the skin, the Titanoboa would take a lesson from the spadefoot toad. This toad secretes a semi-permeable membrane that makes its skin thick, locking in moisture. Our desert Titanoboa would branch out and have a new diet of birds and mammals. Many desert animals are too small to make a meal, so Titanoboa would lie in wait for a herd of camels, slither out of its burrow and make a killing. Or it might go months without food. So, the evolutionary path of Titanoboas could lead to two subspecies. The first one is shark-like, swimming far and wide across the ocean, able to preserve its body heat through adaptations that make it warm-blooded. And the second is also warm-blooded, but lives in burrows deep in the desert, like the sandworms from Dune. They emerge from the burrows with lightning speed, only to strike, eat, and then retreat back underground. These 21st century Titanoboas would be as long as 23 meters and about 1.2 meters wide. Imagine going for a swim in the ocean and running into one of those. You'd have just enough time for one last breath. 6,000 years ago to today. Now, this brings us to the question of how modern-day humans might interact with these magnificent and terrifying creatures. Before the start of modern hunting, Titanoboas would have been legendary, frightening sea creatures that terrified humans. Our ancestors would probably be scared of going in the ocean. Who knows? Any swim could be your last if you encountered a Titanoboa. The only good news would have been that these enormous creatures would probably have little interest in eating you. Because humans would provide little sustenance, they'd rather catch a large fish or crocodile. That would be much more satisfying. Now, as humans developed better weapons, the relationship would have changed. There's evidence of humans hunting whales as far back as 6000 BCE. If the Titanoboa was still around, it may have been a target of fishermen thousands of years ago. Maybe these snakes would become part of our diet. If their meat was tasty, who knows? Maybe humans would have hunted them to near extinction by now. In today's world, it'd be a lot like the occasional shark attack. We'd probably hear about rare Titanoboa attacks on humans who swam too far out into the ocean. In the desert, nomadic tribes would probably fear the random, unpredictable attacks of the desert Titanoboa. Camels would have evolved to be super sensitive to those giant snakes' underground movements. Maybe they'd warn humans when they sensed activity underground. With infrared technology, we'd be able to detect the heat signature of Titanoboas in their underground burrows. Future. But in today's fast-changing world, something new and interesting would be happening. Human activity has reversed the cooling trend. With global warming, temperatures are becoming attractive for reptiles again. Our newly evolved Titanoboas have a warm-blooded inner architecture that has helped them survive the cooling of prior epochs, but as the Earth heats again, the Titanoboa would, once again, lean on the environment for heat rather than using its muscular inner activity. Conditions would be ripe for the Titanoboa to hunt even more effectively and grow bigger. As sea levels rise in future years, our coastal cities will be flooded and destroyed. The warm weather will help new generations of Titanoboa thrive. But the traditional habitats of the Titanoboa are currently being destroyed. The lush tropical swamplands and forests near tropical waters are being wiped out by logging and commercial activity. The growing acidification of the waters will kill the marine life that the Titanoboa feeds on. This would prove to be the biggest challenge for the creature, the destruction of its food supply. But there is one prey left for the Titanoboa. It would have to eat several to make a meal of them, but there's lots around. You guessed it, I'm talking about us. Maybe we'd become the target of the new ferocious Titanoboa. Mars has been on a direct collision course with Earth for weeks now. The destruction has already started with massive tsunamis and earthquakes. Now, our planet is beginning to crack and gravity is significantly changing. But how bad will this be? How could it create a new planet? And is there any way humans could survive? This is What If, and here's what would happen if Earth collided with Mars. 15 days before impact. This won't be the first time Earth has had to deal with a massive collision. Over millions of years, asteroids have rained down on our planet. One of the biggest, the asteroid that wiped out the dinosaurs 66 million years ago. Now, despite its massive impact on Earth and our history, that asteroid was only 10 kilometers wide, about the size of 90 football fields. Mars, on the other hand, has a diameter of 6,800 kilometers, and it's coming straight at us. The red planet is normally about 225 kilometers away from us, but at this moment, it's just 4 million kilometers away. From this distance, it looks like a smaller red moon is approaching us. Now, just because it hasn't made impact yet, doesn't mean we won't be feeling any of its effects. The moon affects the Earth's tides, so what happens when another massive celestial body comes near our planet? Well, the gravitational force would be so strong that Earth's crust would start to bulge and our water would be rising. It could rise so violently that multiple tsunamis become a real possibility. More on that in a bit. 3 days before impact. Okay, now at just 800,000 kilometers away, Mars is twice as far away from Earth as the Moon is. Given its angle of approach to Earth, we'd be looking at a red half moon getting bigger and bigger by the minute. But the red planet is 10 times heavier than the moon and is already tugging at everything on Earth with much greater force than the moon could even dream of. It's creating havoc. At this point, tides are rising 30 to 50 meters high. Deep inside Earth, tectonic plates begin to shift and creak, but it's gonna get much worse. In 36 hours, Mars will reach the same distance away from Earth as the Moon. Then, the tides will rise 10 times higher than usual, 60 to 100 meters. Vast stretches of coastal areas and cities would be flooded. Say goodbye to Miami, Venice, and any other city near a large body of water. Millions of people will drown. There will be widespread panic as people on Earth see Mars's relentless approach. Earth is starting to crack. Earthquakes shake the globe. Volcanoes erupt, covering the surrounding landscape in hot, molten lava. People are running for underground bunkers, grabbing any power source available. Will they make it? Well, getting emergency assistance to one disaster site is challenging enough. Now, imagine trying to do that when you've got countless disaster sites, many in remote locations. And, oh yeah, most of the planet is without power because this incoming collision has wiped out our infrastructure. 4.6 billion years ago. Okay, wait a minute. Before we get into what happens next to Earth, how did we get here? What sent Mars hurtling toward us in the first place? Well, Mars could have been pushed out of its orbit by a rogue planet. This is a planet that exists without orbiting a star. There are billions of these kinds of planets roaming around our universe. They're sometimes hard to detect, though. Why? Well, because they don't give off a huge amount of light, and the light they do reflect is at wavelengths that are incredibly hard to detect. So, it's possible a rogue planet could have entered the solar system undetected, shoved Mars from its current orbit, and here we are. And like I said earlier, it's not the first time a planet the size of Mars has collided with Earth. About 4.5 billion years ago, just after the solar system formed, baby Earth and a Mars-sized planet crashed into each other. You can see it today. The debris from the collision eventually formed the Moon. At this point, people on Earth are in a frenzy, trying to find shelter from this terrifying catastrophe. But violent quakes shake the ground and toss people about. Tsunamis rage and millions of people are drowning. Wherever they can, people are running to underground shelters, hoping for some level of protection. Mars is just 10,000 kilometers away. The gravitational force of Mars and Earth are pulling at each other intensely. Mars is starting to pick up speed, reaching 10 kilometers per second. What's happening now is incredibly interesting. As it's making its way toward Earth, Mars is starting to crack. Why? Well, Earth has 10 times the mass of Mars, and because of this, our planet is exerting gravitational pressure on Mars, causing it to break. Now, there is a possibility that Mars crumbles entirely from this pressure. Maybe the people of Earth live to see another day, but unfortunately that's not likely to happen. Because Mars is moving so fast, there's not enough time for Earth to break the red planet apart. What happens next isn't going to be pretty. 20 seconds before impact. If you looked up now, Mars would be filling up nearly the whole sky. It's now just 200 kilometers above Earth's surface. It's entered the upper reaches of Earth's atmosphere. An enormous shock wave has hit the atmosphere. Due to this, you're finding it hard to breathe. Mars's gravity is pulling at our atmosphere. But that's nothing compared to what's coming next. Cracks in the surface of the Earth will be widening, creating massive canyons. The biggest earthquakes ever don't hold a candle to this. Buildings crumble and entire cities will be reduced to rubble. If you're on Earth as this is happening, well, there's not much you can do. Just hold tight for what's about to happen. Moment of impact. As Mars makes contact with Earth's surface, gravity will be about 30% of what it usually is on the side of the Earth where the crash happens. That's because Mars's gravity is 40% of Earth's, and it's pulling in the opposite direction. Both planets' gravitational forces are now pulling at each other at the same time. But that's only on one side of the planet. On the other side of the world, people will actually be 3% lighter right before they die. Thanks, Mars. That's just when people want to lose weight. Now, at the moment of impact, a massive amount of heat is generated, the equivalent of billions of nuclear bombs exploding. After the initial collision, these two rocky planets briefly separate, but that doesn't mean the battle is over. They'll eventually come together again and recollide. Now, with the amount of heat generated, both Earth and Mars will get liquefied. A shockwave will rock Earth, reverberating through the entire planet, all the way to the other side. Within 20 minutes, everyone on Earth would feel the impact. And everything on the surface of the planet will burn, creating a mass extinction that no living thing could survive. Earth's surface will crack open down to its core. Mars will have broken apart. Large pieces of Mars's core will embed themselves into Earth's core. The entire top layer of the planets will be molten lava, and our two mantles will be mixing together. The energy from the collision will change the speed of Earth's spin. We might spin faster or slower, we don't know. And molten debris from the crash gets ejected into the sky. Smaller bits will fall back to Earth as molten lava, while the larger pieces will start to orbit Earth, forming a ring. Some of the debris will collide with the Moon, and some will be ejected further into space, hitting Venus and the asteroid belt. Over millions of years, the debris collisions with the Moon will make the Moon bigger and heavier. After the collision, part of Mars will be incorporated into Earth. Earth will be slightly heavier. Now, since Mars is 10% of Earth's mass, well, maybe Earth would weigh about 5% more than before. But this new Earth will be devoid of life. Could life ever emerge again on what was once our blue marble? Well, without an atmosphere and without water, it's hard to see how this would happen. Maybe in the future, comets will crash into Earth delivering water, and over billions of years, life might begin again. But with the sun getting hotter and hotter, it's likely going to boil off that water within the next billion years. Prospects for new life on Earth don't look promising. If I told you that in another universe, Earth could be shaped like a donut, well, you'd probably think I'm crazy. But theoretically, it could happen. This alternate Earth might also be squeezed into the shape of a dumbbell. Or it could even be flat. Okay, maybe that one's a bit harder to pull off, but Earth could be many strange and different shapes. Today, I'll take you through 7 of the weirdest possibilities. Some shapes can be incredibly dangerous, while others might be better in some ways than what we have now. Number 7. Donut Earth. On a donut Earth, or a torus-shaped Earth as the science community likes to call it, gravity would be very different. Depending on where you're standing, you could weigh up to 3 times less than what you weigh right now. Our current round Earth has a surface gravity of 1 g, but things would be a bit different on a donut Earth. At the poles, the surface gravity would be 0.65 Gs, while near the equator, it would only be 0.03 Gs. You'd feel like you're bouncing around on Mars. Also, the Moon would act strange. It could behave in 2 different ways. It might be pulled toward the hole and bob up and down in the middle like this, or it might be affected by the gravity of the donut's outer edges and create this figure-8 movement. This would affect the ocean tides and cause unstable water levels, destroying cities that sit on the coasts. The weather in certain parts of the planet would also be extreme. Massive hurricanes and storms would be wreaking havoc. Now, despite these problems, it would still be possible for humans to survive on this planet. Sure, some places would be inhospitable and it might be hard to travel due to the low gravity, but we could live here. Number 6. Dumbbell Earth. Okay, this next planet falls a little further into the realm of science fiction, but let's go check it out anyway. This is Dumbbell Earth. It's 2 separate planets connected by a narrow middle section. The gravity in this part would be significantly weaker. The middle section would essentially be being pulled in 2 directions by the outer planets. This would create some extreme volcanic activity which might cause the planets to break apart. Crossing between the planets would be incredibly dangerous and, in some cases, impossible due to the gravity. Now, living on either of the outer Earths would feel pretty close to what we have now. They'd have similar gravity, weather, and atmosphere. The main difference would be that each Earth would have different cultures and technology. They might evolve differently and contain completely different species. Number 5. Ellipsoid Earth. Okay, this kind of Earth would be egg-shaped, not the sphere that we're used to. It would still be habitable, but there'd be some major differences from how we live now. Gravity would be stronger or weaker depending on where you stood on the planet. The more narrow parts of the planet would have the strongest gravity, and the wider sides would have weaker gravity. You'd also notice some differences in the weather. Places along the equator would have a broad range of tropical, milder temperatures, and places near the polar regions would be much colder and have more extreme temperatures than what we're used to. But overall, apart from a few differences, a planet like this would be very livable for us humans. Number 4. Flat Earth. Okay, before we have some fun talking about a flat Earth, let's make something crystal clear. A flat planet is impossible, and we definitely don't live on one. Gravity naturally shapes massive celestial bodies into spheres, so a flat Earth would completely alter our understanding of gravity. And it's just impossible. But living on a flat Earth, the air pressure would be a major concern. Gravity would draw too much air toward the Earth's center, leaving the areas around the edge with no air pressure at all. If you lived in Australia, you wouldn't have enough oxygen to breathe. And if you lived closer to the Arctic, you'd be crushed by the weight of the air. You'd also have to consider that a flat Earth wouldn't have a core, and therefore no geomagnetic field to protect us from solar winds. Everyone would get a serious case of radiation poisoning from the sun. Number 3. Cube Earth. Earth now has 6 sides. Unfortunately, none of them are any fun. That's because walking on them would feel like you're constantly climbing up a super steep hill. On this cubed Earth, gravity is strongest at the center of each of its faces. So the further you are away from the center, the more you'll feel its pull. But maybe you won't notice it. After all, you'd only be able to live near the center of each of its sides. That's because due to this Earth's gravity, all the water would be pooled into the planet's multiple centers. The edges would be rocky and barren, unable to support any kind of life. It would also make traveling to the other sides of the planet incredibly difficult or impossible. People on different sides would likely evolve in different ways. And each side would have a different climate and weather. A side that doesn't get much sun might be incredibly frigid, whereas a side that gets lots of sun would look a lot different. Number 2. Hollow Earth. Now, some of the planet shapes we've seen on this list are theoretically possible, but a hollow Earth is anything but that. Gravity would force the hollow Earth to collapse on itself, essentially creating a smaller sphere. But let's assume that didn't happen. Well, there still wouldn't be any life because there'd be no atmosphere. Yeah, there would be no magnetic field because our core would be hollow. No magnetic field equals no atmosphere, and not having an atmosphere would mean a ridiculous amount of solar radiation from the sun would be frying us. Plus, if you somehow managed to land on this planet, well, you'd instantly fly off. A hollow Earth's gravity would be so weak that nothing could stick to it. This planet's shape kinda sucks. Next. Okay, for this last one, we're gonna cheat a little bit. What you're looking at here is known as an Alderson disk. It's like a DVD version of Earth, and it's less of a theoretical planet shape and more of a megastructure that could possibly be created. But we'd need a ridiculous amount of materials. You'd likely need to mine the entire wealth of minerals from planets like Earth, Mars, and a few others, making them completely uninhabitable. And this disk would be massive, able to house billions and billions of people. It would be 241 million kilometers wide. For reference, the circumference of Earth is just 40,000 kilometers. But the people living on this Alderson disk would only be able to live in the middle of the band. Closer to the hole near the sun would be extremely hot, and the edges of the disk would be incredibly cold. Yeah, there's also another major issue with this megastructure. Since it's so big, there's the chance that the disk could collapse in on itself and create a black hole. Yeah, I don't think I like this one. Now, maybe instead of contemplating these crazy shapes of alternative Earths, we should appreciate what we have right now. An asteroid is headed straight toward Earth. Initially, scientists thought it would miss us, but they've made some serious miscalculations. And now, it's headed right toward our giant blue marble. What happens next? Does this mean the end of humanity? Can we change the trajectory of the asteroid? And why might this actually happen by the year 2029? This is What If, and here's what would happen if an asteroid hits Earth this year. Now, this sounds like a fun hypothetical, but an asteroid coming for Earth? It's no laughing matter. It could happen. Scientists had thought that asteroid 99942, also known as Apophis, might hit Earth by the year 2029. Apophis was discovered in 2004, and scientists have been closely monitoring it ever since. At one point, research suggested that the asteroid had a 2.7% chance of hitting Earth. Yeah, scary, I know, but since then, new calculations predict that the asteroid will whiz by Earth at a distance of 30,000 kilometers. Now, considering that the moon is 380,000 kilometers away, this asteroid will be incredibly close. But at least it won't be hitting us. And of course, calculations can be wrong. Let's say that in this case, they are, and Apophis is coming right toward Earth. Way ahead of schedule. The asteroid is going to hit us this year. Okay, let's see what we're dealing with. Apophis is 340 meters in diameter. For reference, that's taller than the Eiffel Tower. But is it the worst asteroid Earth has ever seen? Nah, lucky for us, it's not even close. The Chicxulub asteroid that wiped out the dinosaurs was estimated to be 10 to 15 kilometers wide. So now we're dealing with Chicxulub's little brother. So what does that mean for us? Will humans go extinct from this impact? Well, more on that in a bit, but first, let's look at whether we have any chance of stopping this asteroid. Okay, the first step would be identifying the asteroid, which we've already done. We know how big Apophis is and that it's moving at about 30 kilometers per second. Now it's about the defense measures we could use. There's a couple being looked into right now. One of them being the kinetic impactor. This involves sending a spacecraft to collide with the asteroid, all in hopes of changing its velocity and trajectory. NASA has run some successful tests using this method, so that's an option. Next would be what's known as a gravity tractor. A large spacecraft would fly next to the asteroid, and over time, its gravitational pull would eventually change the asteroid's path. Laser ablation is next on the list of options. Yeah, special lasers could be used to vaporize parts of the asteroid's surface. This wouldn't destroy the asteroid, but it could alter its direction as well as the size and impact of it. Yeah, and last but definitely not least is the final nuclear option. Yeah, that's right. As a final resort, we could nuke Apophis. And with the asteroid's massive size, as well as the lack of time we have before it hits us, this might be the only option. But don't be too quick to hit that red button. Nuking an asteroid can have some serious downsides. It could split the asteroid up, causing it to fragment. Then you'd have dozens more minor asteroids and meteors coming toward Earth, making the impact even more devastating. Yeah, and these wouldn't just be regular asteroids either. Because of the nuke, they'd be radioactive. This would mean that significant parts of the world would not only be impacted with asteroids and meteors, but they'd also experience radiation levels only seen during nuclear warfare. So, what's the best option here? Well, it's tough to decide. Let me think about this for a second. Oh, well, it's too late now. We took too long deciding what to do, and now the Apophis will be here any second. Brace yourselves. You wouldn't get a good look at the asteroid impact, and that's because it landed somewhere in the middle of the Pacific Ocean. This is the most probable spot an asteroid would land, considering the Earth's surface is mostly water. So you might not see the impact, but you definitely notice it. Once the asteroid hit our planet, it would be as devastating as several thousand nuclear bombs going off, just with a lot less radiation. It would make a crater at the bottom of the ocean as big as a kilometer wide. And what would happen next would be even more devastating. The massive impact would create giant tsunamis that would rage worldwide. Several hours after the asteroid touches down, cities along the Pacific coast would feel Apophis's impact. The tsunamis would travel across the Pacific Ocean at jetliner speeds. Places in North and South America like California, Peru, and Chile would face towering waves. Due to the energy from the asteroid, it would likely cause waves taller than 30 meters. Waves as big as this are responsible for one of the most devastating tsunamis ever. In 2004, Southeast Asia experienced a tsunami that generated waves over 30 meters tall, killing over 230,000 people. But instead of waves like these reaching just a few countries, this would be a complete global catastrophe. Not only would the Americas experience these tsunamis, but so would Japan, Australia, and the Philippines. These places would all be devastated by the impact. Tsunamis like these would likely destroy millions of lives. So that's what would happen if an asteroid hit the ocean, but what if it made impact on land? Well, to start, the impact crater would be much more significant. We know that an asteroid's impact crater can be anywhere from 10 to 20 times the size of the asteroid itself. And now there isn't any water to soften the blow, so the diameter of the crater could be as large as 7 kilometers, with a depth of over 1 kilometer. Depending on where it lands, this asteroid could be big enough to devastate entire cities. The initial impact would send a massive shockwave that spreads for hundreds of kilometers. This could destroy entire buildings and seriously damage infrastructure. It would throw tons of dust and debris into the atmosphere. It could get so bad that it could cause an impact winter. This would be caused by a dust cloud temporarily blocking the sun, causing crops and vegetation to die out, which creates even more casualties. Something like this could last weeks or months and be an overall environmental catastrophe. This entire event, during and after, could cause millions of people to be killed, depending on where the asteroid lands. We can only hope that an asteroid collision like this would land as far away from people as possible. Today, we're dropping a massive bomb into the Mariana Trench. But we're not stopping there. We're also going to nuke a hurricane and a volcano. What happens when you drop one of the deadliest weapons known to man into the world's greatest natural wonders? Let's start our nuclear experiment by dropping a nuke into the Mariana Trench. How would you deliver a nuke to the bottom of the Mariana Trench? What would this underwater explosion be like? And what kind of destruction would it cause? This is What If, and here's what would happen if we nuked the Mariana Trench. Welcome to the deepest, darkest depths of the ocean. The Mariana Trench is located in the western Pacific Ocean, just 360 kilometers away from the island of Guam. You'll be traveling down 11 kilometers to Challenger Deep, the deepest point of the trench. Here, you could stack about 30 Empire State Buildings on top of each other before hitting the surface. You'd be among the brave few to venture into these high-pressure, pitch-black, and near-freezing waters. Joining the company of scientists, a naval officer, and even filmmaker James Cameron. But you'll be carrying the most precious cargo of all: the biggest nuclear bomb ever made. Okay, wait, before you worry about what would happen if you exploded a bomb at the bottom of the trench, you'd want to figure out how to get it there safely. If a bomb accidentally exploded near the surface, it could be dangerous for many people. You could think of it as a massive nuclear tsunami. Waves hundreds of meters high, spreading out in all directions. This could create a hazardous situation for the islands neighboring the Mariana Trench, like Guam, Japan, or the Philippines. Luckily, these waves would behave differently than your regular tsunami waves. They would break earlier. That means they'd be smaller and less catastrophic when they reached land. But still, better to avoid this crisis and get that bomb safely down into the trench. To do this, you'd have to protect it from extremely high pressures. At the bottom of the trench, the pressure is so high, it would be like having 100 adult elephants on your head. You'd want to use a special pressure vessel to transport the bomb, just like Operation Wigwam. In 1955, the United States detonated a bomb at a depth of 600 meters. It was twice as powerful as the bomb dropped on Hiroshima. The explosion generated a massive bubble across the water, and deadly radioactive contamination spread across 13 square kilometers. But your bomb would be the largest nuke ever created. More like the Tsar Bomba. This nuclear weapon was over 3,000 times more powerful than Little Boy, the bomb dropped on Nagasaki. And you'd have to take it much, much deeper than the Wigwam test. At the moment of detonation, a bubble of hot steam would expand rapidly. In just a few seconds, it would cover an area of about 1 kilometer. On the surface, you'd see a massive bulge in the water. But it wouldn't reach great heights. That's because you would detonate the bomb so deep that the water pressure above would cause the bubble to collapse. But within a few seconds, that bubble would shrink, then start to expand outward again. This expansion and contraction would continue for 3 or 4 cycles. This would leave the water turbulent, hot, and mixed with radioactive debris. At least no neighboring coastal cities would have to worry about being wiped out by a tsunami. But you certainly wouldn't see the effects ending there. The increased temperatures from the explosion could create intense hurricanes. And the turbulent waters and radioactive material would have adverse effects on marine life. There would be mass casualties from the explosion. And deep sea fish could be blinded by the bright flash of light. Over time, you could see unexpected or surprising effects on the ecosystem near the detonation site. There are corals as big as cars after the 23 detonations at the US nuclear testing site on Bikini Atoll, not to mention an abundance of aquatic animal life. But you could see mutations of marine life after a while. Now, that's what would happen if we nuked the Mariana Trench, but let's move our nuclear weapons from the sea all the way to the sky. Let's nuke a hurricane. Every year, about a half a dozen hurricanes reach the United States, with effects ranging from heavy winds and some flooding to the decimation of communities, destroying homes and taking lives. Instead of bracing for impact with our sandbags and survival kits, what if hurricanes never hit land at all? What if we could stop these hurricanes by nuking them? How would we do it? Could this cause a nuclear apocalypse? Or would a bomb even stop a hurricane? This is What If, and here's what would happen if we nuked a hurricane. But first, what exactly are hurricanes? Well, they're massive storms that form over warm ocean water near the equator. Hurricanes are tropical storms. The water they form over needs to be above 26 degrees for them to work. This warm water creates humid air, which then gets thrust upwards by tropical winds to create storm clouds. Lighter winds outside the clouds steer them and help them grow. This cycle keeps happening until the storm has winds of at least 119 kilometers per hour. At that point, it's called a hurricane. They're usually about 160 kilometers in diameter and can be nearly as large as the state of Texas. Oh yeah, and did we mention that these things can last for days? You definitely don't want this coming to your home, so let's nuke it. Believe it or not, the idea of nuking hurricanes isn't new. It's been proposed for decades, dating back to the 1950s. The idea works like this. A submarine would travel underwater to below the eye of the storm. Once there, the sub would launch the nuclear bomb, creating an explosion intended to blast out all the hot air and bring in cold air, which is denser. The cold air would slow down the wind and stop the hurricane. Okay, we have our nuke and are ready to launch it. There it goes. And, well, nothing happened. The hurricane is still there. That can't be good. The reason nothing would happen is because of the amount of energy a hurricane produces. According to the National Oceanic and Atmospheric Administration, the heat released from a hurricane is equal to a 10 megaton nuclear bomb exploding every 20 minutes. In 1990, all of humanity used 20% less energy than a single hurricane produces. So the average bombs of today would hardly make a dent on a hurricane. Not only that, the hurricane would carry all that radiation, plutonium, and other civilization-destroying materials from the air down to the land. As if a regular hurricane wasn't bad enough, we'd now have a radioactive one. As it moved across America, it would destroy cities with its wind and water while also dumping radiation on them. Okay, let's try this again. This time, we'll use an even bigger bomb. And we mean really big. To have enough energy and force to stop a hurricane, you'd need more than 100 atomic bombs. But to keep it simple, let's pack all that power into one giant bomb. If we released such a massive bomb, it would surely stop the most epic of hurricanes. But once the dust settles, you'd quickly realize that you destroyed most of the Earth in the process. So, whichever way you attempt it, nuking a hurricane is not a good idea. And, unfortunately, the number of hurricanes continues to increase. Researchers say that the warming of the oceans due to climate change is a reason why hurricanes are getting stronger and more frequent. And no, we can't nuke that problem either. So nuking a hurricane is a terrible idea. Okay, for our last hypothetical experiment, let's try putting these nukes to good use by detonating them inside of a volcano. What happens next? Volcanoes. The ultimate natural force of destruction. They're unforgiving, uncompromising, and unstoppable. About 1,500 volcanoes around the world are considered to be active, with more than 10% of them in the United States. Is there any way we could stop them before the destruction begins? Could we literally fight fire with fire? What if we nuked an active volcano? Would it solve the problem? Or make it way worse? This is What If, and here's what would happen if we nuked an active volcano. Volcanoes are as cool as they are terrifying. They are an incredible force of nature, capable of destroying our lives on their path of destruction. But could we give them a taste of their own medicine? How could we nuke such a fiery inferno? Well, we'd need to bring out the big guns. The nuclear bomb dropped on Hiroshima, Japan during World War II was the equivalent of over 130 million kilograms of TNT. That had plenty of impact. Could we use something like it to blow a volcano to smithereens? First, we'd have to figure out the target. While it's difficult to predict when a volcano will erupt, there are some warning signs. Watch for things like tiny earthquakes, releases of steam and other gases from the volcano's mouth, and bulging from the sides. Sounds like my last date. That being said, whether the volcano will erupt is still a massive educated guess. So let's say that our scientists locked on to an active volcano that's ready to blow. It would be a miracle if they could coordinate with the military fast enough to try and stop it. Ideally, we'd be able to predict it a few days before the volcano was about to explode. This would provide more than enough time for people to pack up their belongings and evacuate without causing the kinds of highway traffic jams we see during hurricanes, tsunamis, and other disasters. With everyone out of harm's way, geologists, volcanologists, and weapons experts would determine any weak spots on a volcano's sides that could be hit effectively. Next, a highly trained crew of pilots would fly over the volcano, drop their payload, and get the heck out of Dodge. If things worked perfectly, as in if they used the exact right amount of explosives and hit the perfect spot in exactly the right way, the top of the volcano would crumble into itself, keeping the magma mostly underground. There might still be some seepage around the base of the volcano, but it wouldn't be anything like how the eruption would have played out naturally. But if we're being honest, it would be like trying to put out fire with gasoline. Geologists warn that trying to bomb a volcano might actually make things worse. A lot worse. The explosion of the bomb, mixed with the buildup of pressure inside a volcano, could amplify the eruption. The force would release even more ash and lava, spreading it even further than it would have gone with the volcano's own power. And that's if we managed to hit the target. If the nuke missed its target, there's still a nuclear bomb being dropped in an area where people live, or at least near enough that they would feel the effects of the radiation. If you had to pick one, which would you choose? Death by lava or nuclear destruction? We can't bomb our way out of this problem, the same way we can't stop magma from building up under volcanoes. Here at What If, we've tried throwing trash and pouring liquid nitrogen into volcanoes. Long story short, it doesn't work. Don't mess with volcanoes. As cool as it sounds on paper, nuking a volcano just won't work. While man-made firepower can be impressive, nature isn't quaking in its boots at what we can do. Millions of years ago, humans were near the bottom of the food chain. Predators, weather, and diseases all posed the threat of wiping the species out. But then, thanks to evolution, humans went from huddling in dark caves to building full-blown cities. How did that happen? This mysterious era was a time when history wasn't officially recorded, but it brought on a ton of innovation that would be the building blocks of our world today. Let's hop in our time machine and take a trip back to the prehistoric era. Okay, first, what is this strange prehistoric era that you've ended up in? Well, this was a time in history when humans began to develop the world we have today. It was comprised of three main ages: the Stone Age, the Bronze Age, and the Iron Age. The names of these ages reflected the primary materials that humans were using to make their tools. But these materials also provided so much more than simple instruments. They inspired an entirely new society and helped humans evolve into the new world. Let's check it out. The Stone Age. The Stone Age comprised three main eras: the Paleolithic, Mesolithic, and Neolithic periods. The Stone Age began over 3 million years ago, and this was one of the most critical ages for humans and our evolution. One of the most significant advancements of this time was the creation of stone tools. Early humans began making and using tools from rocks and other raw materials around them. One of their tools was sharp pebbles that were used to cut and sharpen other materials. They were essentially just sharpened rocks that humans would hold to make more complex and useful tools. After humans mastered this, they moved on to sharpening other stones used for chopping. These could be used to cut wood or help prepare food. Next, their most complex tool, the hand axe. These were made using multiple techniques. First, you needed to form the rock using a hard hammer technique. Once that's done, you'd refine the thin edge using a soft hammer technique. Today, these tools seem incredibly simple, and you could make them yourself just by looking at them. But millions of years ago, these tools required a detailed understanding of how stone works and how it behaves under certain circumstances. Yeah, this again sounds really simple, but by figuring this out in the Stone Age, humans proved they'd made a significant leap in brain function and problem solving. Another major innovation during this time was harnessing fire. Fire provided shelter, warmth, and protection for humans, allowing them to begin their journey to the top of the food chain. After millions of years of humans playing around with their newly discovered tools, they were able to become much more than just a hunting and gathering society. This is where farming came into play. Humans in the Mesolithic period began experimenting with planting food. As the climate changed, it became easier to grow their own plants in the soil, and more types of food became available. Farming also brought the domestication of animals. Goats, pigs, and cattle all had benefits for humans. They could be used for food, clothing, even labor. Now, once farming and domestication started to take off, well, it brought a shift in settlement patterns. Instead of nomadic humans moving from cave to cave, they were able to start building more permanent homes. Humans in the final period of the Stone Age, the Neolithic period, built on top of these inventions. Instead of just experimenting with seeds, humans began to learn agricultural techniques and were able to plant enough crops to feed their settlements. This period brought new tools and technology and a completely different social structure. With more food and permanent settlements, the population boomed. This led to a division of labor, political structures, and more. The Bronze Age. From 3300 to 1200 BCE was the Bronze Age. One of the key factors of this age was humans discovering how to use metals like copper, tin, and of course bronze in their tools. With these materials, they made more advanced instruments and weapons. ones that would last longer and could be more intricate since metal is more malleable than stone. This also opened the door for artisans and experts to begin working with bronze. They created art that was sought after and influenced culture. Weapons and armor made of bronze impacted how war was conducted at the time. But bronze materials weren't the only new kids on the block. The wheel was invented. This made it easier to move people and supplies. Trade routes between settlements were created. Different settlements could share or sell resources amongst each other, allowing civilization to progress even faster. This led the way for urbanization and the introduction of cities. Settlements in places like Egypt and Greece eventually grew to a point where the population was so big it required some sort of urban planning. This created cities. Society evolved further. Trade, administration, and writing were all starting to come into play. But all of this would have been impossible without food. During the Bronze Age, humanity started to develop mass farming techniques. This was possible because of better tools and an enhanced knowledge of how crops worked. Humans began to understand what crops grew best, where, and during what seasons. The Iron Age. Around 1200 BCE, parts of Europe and the Middle East began making tools with iron. Now, this might sound like a small innovation, but this metal allowed society to make massive technological steps. Iron is much stronger and more durable than copper. This allowed humans to build better tools and weapons. Like, good luck if you were at war with your bronze armor and weapons and had to face an army with all iron gear. The societies with iron tools were the ones in power. Iron was also much easier to mine and more readily available than copper. This allowed humans to make more tools that were economically viable. And more tools means more food that can be harvested, more buildings that can be made, the opportunity for society to progress and flourish. Now, the process of making these tools also required significant innovation. Smelting iron and being able to forge and temper the material required huge technological jumps. But cities weren't limited to making just a few tools at a time. They were becoming production powerhouses. They could produce dozens or hundreds of tools whenever they needed. Ironworking was so popular that over the next couple hundred years, it expanded across the globe. From Scotland to Africa, societies began using iron and learning the methods of building tools. This allowed more cities and settlements to progress and prosper. Expanded trade routes helped with the progress. More cities and cultures could communicate with each other than ever before. The creation of iron tools facilitated the need for different cities to trade and share resources. Another essential tool invented during this time was the iron plow. This allowed us to farm crops more efficiently than ever before, often creating a surplus of food. And of course, more food allowed populations to grow bigger, all thanks to these newfound tools. Around 550 BCE, the Iron Age gave way to the Age of Classical Antiquity, marked by the beginning of humans recording and documenting our own history. And the rest is, well, history. Literally. The sun is releasing massive spurts of energy that are headed directly toward Earth. And if they hit us, it could change everything. Power grids could be wiped out. Our communications could cease to exist. Humanity might be put back into the Stone Age. All because of a solar storm. But what makes them so powerful? How is it possible for something like this to happen in 2024? And why are they so dangerous? This is What If, and here's what would happen if a solar storm hit Earth in 2024. So, how could something like this happen anyway? Well, it all starts with the cycle of our sun. Known as the solar cycle, this is an 11-year stretch in which the sun's solar activity increases and decreases. The cycle starts with just a few sunspots raging about and creating mass amounts of energy, and then 5 or 6 years later, it reaches its peak with anywhere from 100 to 200 sunspots. Then it ramps back down for the last 5 years, and we start another solar cycle. Currently, we're in our 25th cycle since we began tracking the sun in 1755. And unfortunately for us, scientists predict that the sunspots will peak in 2024. This means there's a higher chance that a solar storm will occur. Now, before we get to our solar storm, what are sunspots anyway? Well, they're cooler and darker areas of the sun that are created by a strong magnetic field. They're not directly responsible for creating solar flares, but it just so happens that flares are most common in these sunspots due to their high magnetic activity. The magnetic field lines can become twisted and tangled near certain parts of the sun, and they can suddenly snap and realign, which creates a massive burst of energy. This can result in a solar storm. So now that the sun has released this massive amount of energy, what will happen to you on Earth? Well, when a solar storm occurs, you won't notice it right away. That's because it takes a few minutes before it reaches Earth. And hurry up and get in your last couple of YouTube videos, because once this storm hits, everything changes. Now, the first thing you might notice is that more and more auroras will start popping up worldwide. This typically happens when charged particles from the solar storm interact with the Earth's atmosphere. Although these sights in the sky look beautiful, the good parts about a solar flare end there. Due to the effect on our geomagnetic field, most of our technology would stop working. Things like satellites, GPS, and radio transmissions would become incredibly spotty. Your cell phone likely wouldn't be able to pick up any signal, and communications worldwide would start to fade out or become less reliable. But that would only be if we were affected by a few solar flares. This is an entire solar storm we're talking about here. These are comprised of multiple attacks by the sun on the Earth. But before we get to that, people on Earth aren't the only ones affected by this. Astronauts up in space would also suffer the consequences. Their situation could be a lot worse. The sun would be blasting them with intense solar radiation, and if they're not in a specially shielded area on the spaceship, a solar storm could prove deadly. They could get radiation sickness, as well as develop cancer later on. The solar storm could also destroy their ability to communicate with their mission control, and vice versa. This is just what would happen on the first day of the solar storm, but several days later, as you're still having trouble getting cell reception, another massive attack would come from the sun. A phenomenon known as a coronal mass ejection, or CME for short, would be coming right for Earth. A CME is a massive explosion of plasma and electromagnetic radiation from the sun. This mass ejection can cause violent geomagnetic storms that interfere with Earth's magnetic field. If this were to happen, Earth as we know it could change for good. Just look at what happened in 1859. A solar storm known as the Carrington event occurred. It disrupted and flat out destroyed telegraph communications. Luckily, in this case, Earth was able to recover relatively quickly from what today would be a cataclysmic event. Telegraph communications were a simple technology. Telegraph lines could be repaired quickly and things went back to normal. But what would happen today? Our lives are so much more reliant on technology, and we have so much more of it. This time, the tech interruptions wouldn't just stop with the odd glitch or spotty signal. Instead, a solar storm could be so bad that it would make all technology stop working. Yeah, the intense levels of electromagnetic radiation could wipe out entire power grids and communication systems. Even something as simple as buying groceries with your credit card would be impossible. We're talking about a full-on global blackout. If you were in an airplane, the cockpit could lose communication with air traffic control and not know where to go. Or, with the intense radiation levels hitting Earth, the plane could fall entirely. The same goes for subways and trains. They could come to a complete stop in their tracks. This would cause catastrophes all around the world. Planes falling from the sky, trains crashing. Now, not having power at your house would be the least of the world's worries, because entire cities, including all hospitals, would be without power. No power means it's harder or impossible to treat certain patients. The lack of power and technology malfunctions could cause millions of people to die. The solar flares and CMEs might last anywhere from a couple of hours to a few days, but that doesn't mean this event would be over just yet. Because of all the damage to our power grids, communications, and technology, Earth would take some time to recover. It might be weeks or months before we get back to normal. We'd have to rebuild parts of our power grids and communication systems. And depending on the parts needed, well, this might take another several weeks. And take into account the lack of communication that the world would suffer. I mean, talking to your neighbors is one thing, but how would you communicate with another city or country? Global supply chains would collapse. This would delay things even further. But once humanity got all these things sorted, we would rebuild. What once felt like the end of humanity might turn into a simple footnote in Earth's history. The result of a solar storm could be traumatic and life-changing, but humans would live to see another day. So, how likely is something like this? Well, it's tough to predict. We can look at the solar cycles and see how many solar flares occur, but there's no telling if they'll hit Earth or not. And although a solar storm could happen, well, keep in mind that even though we're more reliant on technology than ever before, our technology is also more resistant. Communication technology and power grids are built to withstand various types of interference. NASA is also working on technology to help predict and warn us about solar flares. If one is headed our way, well, here's what you can do to prepare. Keep a well-stocked emergency and first aid kit nearby. Like with any natural disaster, it's important to be equipped with first aid equipment, non-perishable food, and water. You might want to invest in surge protectors and remember to unplug any electronics if a solar storm occurs. Lastly, look into off-grid power supplies, backup energy sources like generators or solar panels. Then just wait it out. The world should return to normal. Mercury is a strange, hot mess of a planet. This rock is the closest one to the sun, but its surface temperatures can plummet to as low as minus 180 degrees Celsius. It has the strangest sunrises and sunsets in the entire solar system, and one day on this planet lasts about 2 years. But you don't have to survive a whole day down there. We're sending our team member Chase on a mission to spend just 5 seconds on Mercury.
Huh. Mercury doesn't sound so bad. I just don't get why it's so cold. It should be flaming hot.
Detecting extreme temperature fluctuations.
Yeah, Mercury is hot and cold at the same time. That's because instead of a proper atmosphere, Mercury has an exosphere. And this exosphere is almost as thin as the vacuum of space. It doesn't contain enough molecules to transfer heat around the planet, and that means surface temperatures go from one extreme to the other. During the day, the surface is blasted by intense sunlight, and that results in severe heat, like 430 degrees Celsius. Then at night, all that heat gets lost in space, and the temperatures drop to minus 180 degrees Celsius.
Well, at least there's no dust storms on Mercury.
Sure, there's no weather and no climate on this planet, but there are plenty of things that can kill you. extreme heat, intense cold, lack of breathable air, severe solar radiation, and if anything goes wrong with your spacesuit, you'll be toast.
Toast or popsicle, depending on where I land. You know what? I've died way too many times to go out there without prep. Rico, fire up the Simulatoratron.
X-29 Sim on standby.
Simulatoratron. Fine. Run the thing. Find me the safest place to land, please, Rico. Chop chop.
Yeah, finding a perfect landing spot on Mercury won't be easy. Mercury is the smallest planet in the solar system, even smaller than Saturn's moon Titan. And its terrain is just as bumpy as its temperature fluctuations. It has so many craters, cliffs, and ridges that finding a flat surface to land on will be a big if. Then, of course, there's the lack of atmosphere, which makes landing even bumpier. Without air resistance, your spaceship will be approaching the surface at a very high speed. So if you're not interested in crashing, you'll need a spaceship with a powerful propulsion system to slow you down during descent. And Mercury's proximity to the Sun complicates things even more. That's because the Sun's enormous gravity causes this planet to orbit the star on an elliptical path. That means that sometimes Mercury is closer to the Sun and other times it's further away. So landing on Mercury would be like trying to hit a moving target while being pulled strongly by the Sun, all the while trying to manage your speed in a place where you can't just parachute down. Yeah, it's hard. If you managed to drop down onto Mercury during its daytime, it would feel like you landed in an oven. The sun on this side of the planet is so incredibly intense that it will roast you alive. And Mercury's daytime lasts a long time. To be specific, one solar day on this planet goes for 176 Earth days. Weirdly, that's twice as long as 1 year on Mercury, as it only takes 88 Earth days to revolve around the Sun. Of course, there's no way you'd last a full Mercury day. You'd cook within minutes. Now, even NASA's spacewalk suits are designed to withstand temperatures of 120 degrees Celsius. Mercury is 3.5 times more scorching than that. Your spacesuit's outer layers would start degrading within seconds. In minutes, your suit's critical systems like life support and cooling would fail and you'd experience instant heat stroke. Then you'd be cooked and die.
Oh, so you're saying I could last 5 seconds on there? That's all I needed to hear. Rico, initiate landing sequence.
I don't recommend that. Your chances of returning to the ship after a 5-second walk on Mercury's daytime surface are, calculating, 0.012%.
Rico, oh my god, you just had to ruin all the fun every time. Okay, what are my other options?
Calculating. Try landing on Mercury's night side.
Okay.
Now, the dark side of Mercury would be freezing.
Detecting the temperature of minus 180 degrees Celsius.
Even your spacesuit's most advanced heating system wouldn't last long in this brutal environment. Within minutes, your heaters would fail and hypothermia would set in. Your body temperature would start dropping rapidly. In only 10 minutes, you'd be dead. And that's if nothing else goes wrong.
Yeah, landing on Mercury's night side is possible, but it would suck. Like, I wouldn't see a thing there. What's the point in going to a whole new planet if you can't enjoy the views? No, I'll take my chances with Mercury's extreme heat. Thank you very much.
Well, hold on. Maybe you don't have to. You could find a landing location between the two extremes. It's called the Terminator Zone.
Ah, the Terminator Zone!
Yeah. This is the zone between the day and night, and temperatures there might be bearable.
Calculating the Terminator Zone temperatures would be extremely hard. The temperature on Mercury drops to the extremes rapidly.
That's true, but this is your best shot at spending 5 seconds on Mercury. And hey, remember I mentioned the strange sunrises and sunsets on Mercury? Well, here's your chance to see them too. Mercury has a double sunrise. It's because it moves on its axis very slowly but orbits the Sun very quickly. At certain points, the orbital speed becomes faster than its rotational speed. And if you were standing on Mercury at that moment, you'd see the Sun rise, then stop, move back, and rise again.
Oh, cool! Double sunrise! Rico, okay, let's do this. Let's land, this time for real.
Landing complete. The temperature reading at 130 degrees Celsius.
Okay, yeah, feeling toasty, but not cooked. Another successful mission for the Astro King and his dumb sidekick Rico. Okay, so when do we get to see this double sunrise?
You must remain on Mercury's surface for a few hours to witness the retrograde sunrise.
Oh, why didn't you say that before we landed? Okay, well, I mean, it's not that bad. I could stick around here for a few hours.
I don't recommend that. The temperature will rise drastically in 3.2 hours.
Oh God, Rico, just say 3 hours. It's fine. I'll be fine, okay? I'll stay right here next to the ship where... Ow! Okay, that rock is hot. Don't read into that. Nice. Rico, what was that?
A micrometeorite hit your spacesuit. You're losing oxygen.
Skay, hot. Can't breathe. Why can't I ever get hit by a macro meteorite? Why does this always take so long? I didn't even see the double sunrise. What if Guy puts it on his Patreon because I subscribed last month at the Red Giant Tier? And then pitched a story where I don't die.
Oh, classic Chase. But don't worry, he'll be back for his next adventure. He always comes back. 65 million years ago, dinosaurs ruled the Earth. They dominated each time period they were in, becoming the kings of the animal kingdom. Then suddenly, that all changed. An asteroid came for Earth and wiped all the dinosaurs out, causing them to go extinct. But what if things were different? Time to turn back the clocks over 65 million years to see just what course evolution would have taken if dinosaurs still roamed Earth. In what ways would their bodies have changed over this time? How would they adapt to our planet's changing environment? And would some dinosaurs remain at the top of the food chain? A food chain that now includes you? This is What If, and here's what would happen if dinosaurs never stopped evolving. Okay, before we reimagine the course of evolutionary history, let's explore just what kind of catastrophic series of events could have led to the extinction of so many dinosaur species in the first place. Going back about 66 million years into our planet's past, the Cretaceous period would be nearing its end. But not before going out with a bang. A big one. No, not that big bang. An asteroid named Chicxulub with a diameter of about 10 kilometers hurtled through space and our atmosphere to its final destination around the Yucatan Peninsula in modern-day Mexico. The impact of this giant hunk of space rock released an amount of energy equivalent to about 100 trillion tons of TNT. This explosion was billions of times more powerful than the atomic bombs dropped by the United States in World War II. In the immediate aftermath, it led to massive tsunamis and widespread fires and filled the atmosphere with so much debris that it blocked the sun. Temperatures dropped, food chains were disrupted. As a result, 75% of all life vanished from Earth. Luckily, in our scenario, they'll never know what didn't hit them. Okay, when you look back through the evolutionary history of life on Earth, it's important to remember that it's always been a game of survival, and only the fittest species survive. That would mean that of all the dinosaur species that ever existed, not all of them would survive the millions of years of natural selection to still be around today. But let's see if a couple of our most famous prehistoric friends make it through this genetic gauntlet. Starting at the top of the food chain, one of the greatest apex predators of all time, the Tyrannosaurus rex. Many millions of years ago, a T-Rex would have used some of its highly sophisticated senses to hunt prey. These beasts likely had a range of vision similar to or better than hawks and eagles. The science suggests that throughout the T-Rex's evolution, their sight improved as their facial structure became narrower and their eyes grew larger. After many more millions of years of evolution, well, their vision might have improved to unfathomable levels. Instead of spotting prey hundreds of meters away, they could see their next meal several kilometers in the distance. But what about other parts of their bodies? Well, besides their notoriously tiny arms, the T-Rex was a towering figure, standing just under 4 meters tall. Over time, natural selection might have favored T-Rexes with longer, more muscular arms. By now, they might have developed better agility and range of motion to become even more formidable predators. And they wouldn't be the only predators that may have become even more dominant over time. Velociraptors were famous for their speed, agility, and hunting techniques. And they were intelligent, too. Okay, maybe not as bright as movies like Jurassic Park make them seem, but certainly they had a leg up on some of their dumber plant-eating prey. With millions more years of evolution, these creatures would have developed highly advanced hunting techniques. You know, another thing Hollywood doesn't show you is that evidence suggests that raptors were likely covered in feathers, and that their evolutionary trajectory is very closely linked to the emergence of birds. Imagine over time that these feisty predators evolved to have wings and could hunt helpless prey, like humans, from the skies. Well, more likely it would be your pets you'd have to worry about. Velociraptors were smaller dinos, only about 45 kilograms and less than 2 meters in length. But keep an eye on Rufus and Garfield. And maybe on the small children, too. Now, in terms of dinosaurs that already dominated the skies, well, the aviation skills of pterodactyls would have also continued to develop and improve. By the time they went extinct, these creatures were the largest known flying animals, with wingspans ranging from 2 to 11 meters. Ugh. If they continued to adapt to our planet's changing atmosphere and geographical shifts, well, who's to say these gigantic flying reptiles wouldn't have continued to grow? You imagine a day in the park ruined by the surprise visit of one or more pterodactyls the size of a small building. Now, that's something you'd have to worry about. Not all dinosaurs would have evolved to become bigger, badder predators. Okay, maybe gentle giants like the Brontosaurus could have continued growing in size, but they might have developed other features to make them less vulnerable to predators. For example, their skin. Natural selection might have favored those with increasingly thicker outer layers that could withstand the powerful bites of creatures like the T-Rex. Or whatever it is the T-Rex would be known as now. Like for the other species, there'd be so many enormous environmental changes between their era and now. The Brontosaurus was a herbivore, and as plant species underwent their own evolutionary process, well, these dinosaurs would likely have developed a more complex digestive system, similar to those of mammals. And this brings up another interesting dilemma. If these creatures never went extinct and kept evolving, uninterrupted by a pesky space rock, would mammals like you be here today? Yeah, our earliest human ancestors evolved among creatures like mammoths and saber-toothed tigers, but now that we're adding in all these other species, only the fittest would survive. And in that case, human evolution could have taken an entirely different course too. Natural selection would have likely favored genes that would make us smaller and faster to avoid being eaten. And with the possibility that we'd be living among other highly intelligent species like raptors, our social structures might be completely different too. Instead of being the most dominant species on the planet, well, there's a strong chance we'd have to compete with these other dangerous predators. If at any moment we could be raided by a pack of vicious T-Rexes, would we ever have settled down in one place? Instead of human civilization evolving in great communities, well, maybe we'd only survive as solitary, nomadic hunter-gatherers. Evolution is a mysterious puzzle that only time knows the answers to. If you were born and raised on Mars, your body would look very different. Mars might be the best candidate for humanity's future space settlement, but as far as gravity, breathable atmosphere, and liquid water go, it ain't the kind of place you could survive. At least not in your current state. If you tried to walk on the red planet without a spacesuit, you'd suffocate, swell, and die of extreme radiation poisoning within minutes. Yeah, that wouldn't be pretty. To survive Mars's harsh environment, you'd have to be taller and leaner. Martian gravity is only about 38% of Earth's gravitational pull. That means you wouldn't need much muscle power to walk around. You'd lose bone and muscle density, but that's okay. Your taller frame would use less energy, and that's good news because food on Mars would be pretty scarce. Plus, being taller would help you see further. Speaking of sight, your eyes wouldn't be the same. Mars is known for its dust storms, and it's not as sunny here as it is on Earth. Your eyes would have to adapt. You'd see better in low light, and your tears would be sticky to protect you from all the dust and debris. Now, Mars barely has an atmosphere, and that means two things. First, your lungs would become super lungs, capable of extracting trace elements of oxygen from the Martian atmosphere. And second, your skin would be dark brown to protect you from the harmful solar radiation. Yeah, without a dense atmosphere, Mars gets bathed in radiation. It also gets extremely cold on the red planet. Thanks to almost zero atmosphere, the temperature here ranges from a comfortable 20 degrees Celsius to a freezing cold minus 153 degrees Celsius. But your dark skin would absorb more heat to help you survive when it gets chilly. What if you were born on a much hotter planet than Mars? Well, welcome to Venus. It has a dense atmosphere which traps the sun's heat and turns the planet into a furnace. It's so hot on Venus that if you walked outside without a spacesuit, you'd instantly be incinerated. You'd also get crushed under the extreme atmospheric pressure, 92 times higher than Earth's. Evolving to live on this hellish world would mean having a short and sturdy body with thick silver skin. Yeah, your skin would have to reflect the intense heat and radiation. It would also need to be able to neutralize sulfuric acid. Yeah, that's right. Venus has a thick carbon dioxide atmosphere with clouds made of sulfuric acid droplets. So you'd need to be ready to withstand the Venusian acid rain. And your shorter, more compact body would provide the necessary support to withstand the extreme atmospheric pressure. But you still couldn't breathe the toxic Venusian atmosphere. You'd need to rely on oxygen tanks. You'd also never have an active lifestyle on Venus because you'd need to conserve your energy and whatever oxygen you could get. You'd pretty much be stuck in your living quarters the entire time. Yeah, living on Venus would be difficult, even with an extremely sturdy skeleton. So let's try another planet, like Mercury. Mercury is even closer to the Sun than Venus. On Venus, you'd have to worry about scorching heat. On Mars, you'd have to adapt to freezing temperatures. Well, on Mercury, you'd be dealing with both. Just like Mars, Mercury has almost no atmosphere, so temperatures on this tiny planet range from a blazing 427 degrees Celsius during the day to a frigid minus 179 degrees Celsius at night. And one night here lasts almost 3 Earth months. You'd need a thermal insulation layer under your skin to stand a chance on this planet. It'd make you look metallic, just like on Venus, but it would help reflect the incredible heat and then retain that heat once the temperature dropped. Your body would evolve to be sturdy and stocky, with a layer of fat helping to keep you warm during cold nights. But your limbs would be longer and more flexible so you could move around easily. You wouldn't have much muscle because Mercury's gravity is only about 38% of Earth's gravity. You'd develop cells resistant to radiation. That's because Mercury is 3 times closer to the sun than Earth, and it has no atmosphere to protect you. And breathing on Mercury would be impossible. Maybe you'd have smaller lungs capable of storing oxygen. You might even evolve to have a special organ that could produce oxygen from the minerals you ingest. Kind of like how plants make oxygen through photosynthesis. Life on Mercury would be pretty miserable and uneventful, but wait till you see what life could be like on Jupiter. Okay, here's the thing about Jupiter. It's not made to live on. First, it doesn't even have a surface for you to walk on. You'd be gliding through clouds of hydrogen and helium. You'd lose bone density, but your muscles would be strong. And you'd have to be short and compact to withstand the intense pressure of the gas giant. Your dark skin would give you some level of protection against Jupiter's radiation, and you'd be full of gas. Yeah, in order to be able to fly in Jupiter's thick atmosphere, your body would need to have lighter-than-air gases. Your biggest problem would be breathing. You could adapt to the extreme radiation levels and high atmospheric pressure, but Jupiter has 0 oxygen in its atmosphere, so unless you could evolve to breathe hydrogen or helium, you wouldn't survive long on this planet. And it's the same story on Saturn. Only there, you might evolve to have specialized organs that could synthesize breathable oxygen from water vapor or ammonia. So, more points for Saturn. On Uranus, you'd look like a short blue alien. That blue pigmentation could give you some protection against cosmic radiation. Your skin would need to be very thick and have the ability to retain heat well. Uranus is cold. It's one of the coldest planets in the solar system, reaching freezing temperatures of minus 224 degrees Celsius. There's no way you could breathe on Uranus because, just like on Jupiter, there's no oxygen on this ice giant. And no solid surface either. Uranus is like a giant cloud of farts. Yeah, thanks to hydrogen sulfide and its clouds, this planet reeks like rotten eggs. So maybe it's best you don't breathe in all that stink. Being born on Neptune would be exactly like being born on Uranus, minus the fart smell. Neptune is slightly warmer than Uranus, but that wouldn't be enough to make this ice giant habitable. Even with a body designed for this planet, you couldn't survive here.
Asteroids, volcanoes, a lack of oxygen. These were just some of the ways that life was almost snuffed out on our planet. But against all odds, humans have managed to survive. So how did we go from tiny molecules to taking over the entire world? Well, we'll take you on a journey through time that explores the evolution of humans in 20 minutes. Who the heck is Luca? Is it evolution's fault that we're all wearing braces? And wait a minute, do we all really have the same great-great-great-grandmother? 4.5 billion years ago. 4.5 billion years ago, something absolutely mind-blowing happened. And I'm not talking about the Big Bang. Believe it or not, this second act might be even wilder. I'm talking about abiogenesis, the beginning of life from non-life. Imagine a soup of ammonia, methane, and hydrogen in a hot broth of water. This could be cooking in a volcanic vent deep in the ocean. Instead of curry powder, Mother Earth probably added some sulfur, nickel, and iron to the broth. Molten rock underneath then heated things up 3.5 billion years ago. Before we humans can enter the scene, we need one very important thing, and that's oxygen. Earth used to be full of nitrogen, hydrogen, water vapor, and carbon dioxide. It wasn't until cyanobacteria came along that we got the precious oxygen that we humans need. 1 billion years ago. Fast forward to 1 billion years ago, when Earth was shifting around, creating different supercontinents. You had Rodina, and then a couple of 100 million years later, another supercontinent, Pannotia, formed near the South Pole. This was also a time when single-celled organisms were starting to form into the first simple animals. 550 million years ago. 550 million years ago, one of the most critical events in our history took place, the Cambrian explosion. This is when hundreds of different animals burst onto the evolutionary scene. It was the building block for every major animal we know today, including you. 66 million years ago. The dinosaurs ruled Earth for hundreds of millions of years and survived multiple extinctions, but all good things eventually come to an end. 66 million years ago, an enormous asteroid hit Earth, landing on the Yucatan Peninsula in today's Mexico. It coughed up a ton of debris, blocking the sun. This finally wiped out the dinosaurs. This might seem like an insignificant event for us humans, but this extinction opened up the spot for mammals to become the leaders of the animal kingdom. 40 million years ago. These mammals included small, furry ancestors of all primates. The early primates were similar to the small rodents we see today. They lived and multiplied in a unique ecological niche, eating an omnivorous diet of fruits and insects. They continued to evolve, and their brains grew bigger. Without competition from the dinosaurs, they were able to grow exponentially. After millions of years of evolution, monkeys were seen in Africa, Asia, and South America. Fast forward another several million years, and apes evolved. Then the orangutan lineage split off. Soon it would be our turn. 8 million years ago. Then, about 8 or 9 million years ago, human, a common ancestor to both chimpanzees and humans, split into two lines, chimpanzee and human. For a long time, biologists thought this was a clean split that created separate chimpanzee and human species, but they were wrong. The two lines continued to mate and exchange genes for millions of years. It may have taken a full 4 million years before the two species fully broke from each other. Even today, though we're a different species, humans share an astonishing 98 to 99% of our genes with chimps. So, 5 to 6 million years ago, the Homo genus became distinct. Despite being a separate line, our ancestors were still pretty ape-like. You may have heard of Lucy, a 3.2 million year old ancestor from Ethiopia. Her brain was tiny, chimp-sized. The secret to big brains had yet to be discovered. And Lucy had long arms. She probably spent a lot of time swinging in the trees at night. But there was one important feature that separated early humans, including Lucy, from apes. We were bipeds, walking on two legs. What led to that? Well, there are two explanations for what got humans walking upright. The first is the savanna hypothesis. According to this, when forests retreated and savanna spread, humans spent more time foraging among the grasses, and walking upright allowed them to see better, like an SUV that towers over all the sedans. However, after studying chimps in western Tanzania, some scientists believe early humans mostly walked upright in trees. This may have been to gather fruit in the upper branches or to escape predators, but this theory has got some explaining to do. For instance, it can't explain why humans became bipeds but chimps didn't. Then How about them kangaroos? 2.6 million years ago. About 2.6 million years ago, early humans started getting the hang of things. Their brains began developing further, which allowed them to start making tools. The species behind this was Homo habilis, sometimes known as handyman. The early tools were only sharpened stones. It took another million years for humans to make hand axes, but we'll get to that in a bit. Scientists don't believe these early humans were fearless hunters. They were probably mostly scavengers, eating leftovers from the kills of saber-toothed tigers. They used their tools to cut up carcasses and break bones to get to the nutritious marrow. If they got lucky, they also ate zebras, elephants, rhinos, buffalo, and giraffes. But mostly, they were just eating salad. It's no surprise that early humans weren't all that fearless. Life was dangerous. We see some pretty gruesome deaths in the fossil record from 1 to 2 million years ago. One adolescent was caught by a leopard and dragged up a tree. A 3-year-old was likely picked up by an eagle with its talons digging into the child's skull. And if it wasn't a leopard or an eagle, gum disease might get you. One kid got an infection after a baby tooth fell out and died of sepsis. Scientists even found a woman who died of vitamin A poisoning. Maybe she binged on animal liver. I don't know about you, but I'm feeling pretty lucky that I live in the present. 800,000 years ago. Then, 800,000 years ago, early humans learned a new valuable skill. Not only would this change the path of history, but it would give today's dentists something to do. But more on that in a second. Humans learned to control the use of fire. This meant we could keep ourselves warm, scare off predators, and cook meat. With humans eating more meat, this caused our most important organ to grow larger: the brain. But there was a downside to all this new delicious cooked food. It was now softer and easier to eat. This led to humans needing to chew less and our jaws becoming smaller. And a smaller jaw means we were more likely to have crooked teeth due to crowding. Take a look at this caveman's teeth. Yeah, perfectly straight because of the larger jaw size. 400,000 years ago. Okay, now that humans had fire and food, they were looking for a better form of shelter. They didn't want to live in dark and dingy caves any longer. They decided to start building houses. Now, the oldest building we have a record of is from 400,000 years ago, located in France. This is also when Homo heidelbergensis enters the picture. They're a key extinct species of human that were ancestors to Homo sapiens, Denisovans, and Neanderthals. Between 300,000 and 400,000 years ago, a group of Homo heidelbergensis moved from Africa to Eurasia. One subgroup moved west to Europe, becoming Neanderthals. Another subgroup moved east into Asia to become Denisovans. A little later, we'll tell you about interspecies romance, so keep these players in mind. Meanwhile, back in Africa, 300,000 years ago, a gradual evolutionary transition began from Homo heidelbergensis to the first of our species, Homo sapiens. In another 150,000 years, these archaic Homo sapiens further transitioned and evolved into the humans we know today. Fossil evidence helps us to see a transition in the physical features. The size and shape of the forehead, the brow ridge, and the face changed over time. Homo heidelbergensis had a more prominent brow ridge and a projecting face. Modern Homo sapiens skull was more rounded and bigger, and they also developed a higher forehead. 200,000 years ago. About 200,000 years ago, sometime in the middle of this transition from archaic to modern, a key female ancestor was born. Scientists now call her mitochondrial Eve. The DNA of each and every one of us tracks back to her. Think of her as your great-great-great-great-great-great-great-great-great-grandmother. Okay, we've got fire, shelter, and a great-grandma, but life was still hard for early humans. Anything could kill you. Diseases, a fight over a giraffe carcass, encounters with animals. In Africa, it was lions or venomous snakes. In the Asian tropics, tigers. In the Americas, cougars and jaguars. So the average life expectancy was only about 30 years. The total number of humans on Earth was probably under 1 million. 74,000 years ago. Then, 74,000 years ago, our fragile existence was threatened. A supervolcano erupted. There was a massive global climate disruption. Africa experienced increasingly dry conditions. Homo sapiens came close to being wiped out. Maybe only 600 to 10,000 adults of reproductive age survived. During this difficult time, humans seem to have broken off into smaller, isolated groups. As the area became drier, rivers shrank, but this made aquatic life easier to catch, so for a while, humans ate more fish. Ultimately, the fish may have been depleted, and this was one of the likely reasons that they left Africa. 60,000 years ago. About 60,000 years ago, modern humans began migrating out of Africa. With waters receding, new travel routes might have become more accessible. Humans first went to Asia. By 45,000 years ago, they were settled in Indonesia, Papua New Guinea, and Australia. Now, remember I said we'd tell you about romance with Denisovans? Well, in Asia, Homo sapiens mated with Denisovan populations. Denisovan DNA is 3 to 6% of the genome of specific Asian populations today. 40,000 years ago. Now, around 40,000 years ago, Homo sapiens made it to Europe using two paths. They got into Eastern Europe from Turkey, and the Mediterranean coast was another route. Here, Homo sapiens mated with Neanderthals in Europe and acquired genes related to skin and hair growth from them. Those cute freckles that you see? That's from the Neanderthals. Now, around 15,000 years ago, Homo sapiens went from Asia to North America. But how? Well, remember, the topography was different. Though today's continents were in place, a piece of land formed a bridge between Asia and North America for 5,000 years. It was called Beringia, and it connected eastern Siberia to Alaska. After making the trek to North America, some traveled down to South America. Now, this was the point in time when all other Homo species became extinct, leaving Homo sapiens as the only remaining humans left. We don't know exactly why this happened, but research suggests that it may have been due to us having better survival rates, or the other species were just outcompeted in some way. 12,000 years ago. Then, 12,000 years ago, we reached a major turning point. Humans began to master farming. They grew wild varieties of peas, lentils, and barley, and began herding goats and oxen. The first farmers lived in the Fertile Crescent, a region in the Middle East, but there wasn't just one group. Multiple unrelated groups, isolated from each other, all pursued farming around this time. As humans became farmers, population growth picked up. By 1 AD, our population was about 170 million. In the 14th century, we were hit by the bubonic plague. It wiped out 50 million people of a worldwide population of just about 450 million. It took 2 whole centuries for Europe's population to recover to pre-plague levels. 250 years ago. 250 years ago, the Industrial Revolution began. Our world transformed from rural and agricultural to urban and industrialized. Our population started to grow rapidly. We hit 1 billion people in 1804, and in 2023, we were at 8 billion. Our growth has been exponential, but humans have needed vast amounts of energy. First, we got this from coal, then from oil and natural gas. Now, we're on the path to harvesting solar power, discovering new technology, and space travel. Who knows what the future holds for humanity?
Yeah, all right, let's shake things up a bit. Our solar system has been around for billions of years and is starting to get a little boring.
So what if we shook up the positions of our planets? What if Jupiter was right next to the Sun? Or what if Earth switched places with Mars? Today, we're rearranging the planets in our solar system from largest to smallest, and then flipping them back to go smallest to largest. But how would this affect Earth? And would we have a new planet to call home? This is What If, and here's what would happen if the planets changed positions. Okay, first let's take a look at what would happen if the planets were laid out from largest to smallest, starting with the Sun. Well, this configuration has a big problem. But before we tell you what that is, let's look at how the individual planets would line up. Jupiter is the granddaddy of the solar system. It's more than twice as massive as all the other planets put together. It would move from its current position all the way to Mercury's spot, placing it less than 1/10 of its original distance from the Sun. Think that's a crazy idea? Well, astronomers studying exoplanets tell us that this is not so unusual. Other large gaseous planets orbiting very close to their stars have actually been named hot Jupiters. Now, sitting in Mercury's orbit, Jupiter's orbit around the Sun, a trip that normally takes 12 years, would now take just 90 days. And the average temperature would rise to around 167 degrees Celsius, making Jupiter's gaseous atmosphere heat and swell. And what would happen to Jupiter's moons? Well, the icy layers of the moons Ganymede, Callisto, and Europa might start to sublimate, forming water vapor, revealing the oceans beneath. But that wouldn't last long. Given the intense heat of the Sun, the water would evaporate. Now, if there's any life in Europa's ocean, it might welcome the warm thaw, only to quickly realize things are a bit too hot to handle. Okay, in second position behind Jupiter would be the gas giant Saturn, taking the place of Venus. Things would be warming up here, too. The average temperature of Saturn would climb from minus 140 degrees Celsius to 55 degrees Celsius. And in its new position, Saturn would look a lot different. Now, bombarded by the intense heat and radiation from the Sun, the planet's rings would disappear. The rocks found in the rings might survive, but the ice particles would melt and the dust would get blown away by solar winds. But who knows? The magnetic fields of Saturn and the Sun might interact and form brand new patterns. Okay, now we get to the best seat in the house, the Goldilocks zone. Yeah, unfortunately, Earth no longer gets this spot. We'll check in on our new home in the solar system in a bit, but for now, the habitable zone is occupied by our third largest planet, Uranus. Now, normally, it takes Uranus 84 years to revolve around the Sun, but here, that shrinks to just a single Earth year. And instead of it being a cold, barren planet, it would now be basking in the Sun's rays. So, would this transform the ice giant into a habitable planet? Well, for habitability, you need three things: liquid water, carbon-based molecules, and an energy source. Well, with more heat from the Sun, water ice in Uranus's atmosphere could become liquid water, so we can check that off the list. Now, what about carbon-based molecules? Well, luckily they exist in Uranus's icy atmosphere of methane and ammonia. Check. And in its new spot closer to the Sun, there'd be way more energy available, so yeah, looks like we got everything we need. But not so fast. Remember, Uranus has super high atmospheric pressure and also lacks a surface. So the chances of this ice giant becoming Earth 2.0 are pretty slim. Maybe Uranus's moons would be a better spot to live. Or maybe things would improve for Uranus in a couple billion years. After all, Earth wasn't the most habitable planet at the start of its life either. Yeah, but there's no time for that. We've got more planets to check out. Alright, in the number 4 spot, we've got Neptune, filling in for where Mars would normally be. Moving this ice giant so much closer to the Sun would start warming it up considerably from its current minus 200 degrees Celsius. It would also go from having an orbit of 165 Earth years to being able to zip around the Sun in just under 2. But Neptune is known for having violent storms, and due to the increased heat and energy it would get from being this close to the Sun, its storms might get even worse. Okay, I bet you're wondering about that big problem I was talking about earlier. Well, this new planet order would be seriously destabilizing. We've got 4 big planets now crammed into orbits that are very close. As these large planets swing around the Sun, they'd exert huge gravitational pull on each other. This could tear the system out of whack, destroying our entire solar system. And even if that doesn't happen, something terrifying would happen to us in this newly redecorated solar system. In this new order, Earth would be the 5th planet from the Sun, sandwiched between Neptune and Venus. Now, if Earth were to orbit too close to Neptune, we could become the planet's 15th moon. Oops. But really, that might be our best case scenario. Being so much further away from the Sun, we'd now be getting less energy. Our surface water would freeze. All life on the planet would die out, including you. The only things that might stand a chance are a few creatures living inside deep-sea hydrothermal vents, being heated by the Earth's core. Anyone want to be a snailfish? Okay, after Earth would come Venus, then Mars, then Mercury. This far away from the Sun, temperatures would plummet on all 3 planets. Venus's sulfuric clouds would condense, forming acid rain, sulfuric acid ice, and carbon dioxide ice. Not the kind of ice you want in your whiskey. Mars and Mercury, with little to no atmospheres, would become cold ice boxes orbiting the Sun. Yeah, none of this sounds great. I think I like the current order of the planets that we have now. But what if we tried this in reverse? What if we arranged the planets in ascending order, with the smallest one closest to our Sun? In this case, hot little Mercury would be in position number 1. Yeah, just like today, so far so good. In orbit number 2, we'd find Mars. Mars would get toasty, reaching an average temperature of 32 degrees Celsius. Like a hot day here on Earth. But any surface water might get vaporized, and carbon dioxide in the ice caps and in the soil would get released. Would this lead to a thicker atmosphere? Well, probably not, as the atmosphere would likely get stripped away by strong solar winds. So, unfortunately, the red planet won't become any more habitable with this new positioning. Okay, now we reach our happy place, the habitable zone. Would pulling Venus into the Goldilocks zone create ideal conditions for life? Sorry folks, it doesn't look good. Sure, Venus would cool off a bit, but not enough to sustain liquid water, which is essential for habitability. Venus's carbon dioxide-rich atmosphere makes things hot through an intense greenhouse effect. There's no water on Venus's surface and very little water vapor in the atmosphere. Even if a comet crashed and delivered water here, it would evaporate in the heat. So, big thumbs down for new life. And how about Earth? Well, we'd be in 4th place. This would mean we'd get just half as much sunlight as we get today. That's not so bad, right? Well, unfortunately, this means we'd freeze. Similar to our other scenario, maybe some small pockets of life could survive, but humans wouldn't stand a chance. Without being in that perfect habitable zone, Earth just wouldn't be the same. In 5th place is Neptune, which is closer to the Sun compared to where it is now. Now, Neptune's gravitational field might ward off some asteroids headed toward Earth. It would also make for a beautiful night sky, with Neptune shining brightly, second only to our moon. Further down the line, Saturn and Uranus would swap places, with Uranus coming in and Saturn moving out. probably wouldn't change things all that much. Jupiter moves from 5th place to 8th place, 6 times farther away from the Sun than before. That's a big change. 1 year on Jupiter would now last nearly 14 times as long as before, from 12 Earth years to 165. Its hydrogen and helium atmosphere would stay pretty much the same, but the weirdest thing that might happen? Being this far out, Jupiter's gravity would have an effect on meteors, asteroids, and other rocks flying around the outer solar system. And due to its significant gravitational pull, Jupiter would attract them and begin to fling them around the inner solar system. It would be like the late heavy bombardment experienced by the early solar system. Planets would get hit with significantly more asteroids than they do in our current formation. I'm glad the planets aren't laid out from the Sun based on size. Big to small or small to big, either way, things wouldn't be good for Earth. We'd freeze and die. Life would cease to exist. Now, how did we get to the current order of our solar system anyway? 4.6 billion years ago, our solar system started off as a big blob of gas. Some of this collapsed due to gravity and formed the Sun, and other bits came together to form the planets. There was still a lot of gas and dust around, which concentrated into a dense, rotating disk. The rotation of this disk affected the positions of our planets. The smaller rocky planets, Mercury, Venus, Earth, and Mars, were pulled inward toward the Sun. And further away from the Sun, gas and ice condensed to form Jupiter, Saturn, Neptune, and Uranus. A second transformational phase began 3.8 billion years ago. The orbits of Jupiter and Saturn became locked together briefly, creating instability in the solar system. To counter that instability, their positions changed. Jupiter migrated inward and Saturn, Uranus, and Neptune migrated outward. After a few million years, things settled down with all 4 assuming positions similar to where they are today. Regardless of how it all happened and why the planets sit where they do today, I'm just happy the Earth ended up in the Goldilocks zone.
Imagine a future world where you have endless supernatural powers. You can hop through the multiverse and bend time to your will. You'd be part of a super advanced version of humanity, a Type 7 civilization. Yes, please. But how do we get here? Today, we're taking you on a journey to the future to show you how humanity could progress from a Type 0 civilization all the way to a Type 7. Now, before we visit these super advanced civilizations, let's take a second to talk about the scale we measure them on, the Kardashev scale. For starters, you're probably wondering why it's called the Kardashev scale. Well, this scale is the brainchild of Russian astronomer Nikolai Kardashev, who proposed a system for classifying how advanced a civilization is. It's kind of a tricky problem because civilizations change over time. Take weapons, for instance. In the Stone Age, having a really sharp stone made all the difference. But it's hard to measure advancement based on how many sharp stones a society had, because now our weapons are all bombs. Kardashev realized he needed to hit on a metric that's a fundamental characteristic of civilizations. He decided that had to be energy. He classified civilizations by how much energy they're able to harness and use. Now, Kardashev only defined type 1, 2, and 3, but others have since expanded on his definition to add types 4 through 7. Okay, now that you know what the scale represents, let's take you on an epic tour to explore each of these civilizations. Our first stop, naturally, a type 1. But before we set off for a type 1, let's take the pulse on where we are today on our blue marble. Well, type 0. Yeah, despite all the progress we've made as a species, we're living in a civilization that still hasn't reached the first rung of the ladder. Heck, we're still burning dead plants for energy, using just 1/1,000,000th of the energy that the sun splashes on our planet. And we have zero control over natural disasters. If
If a supervolcano erupted tomorrow, we'd all be dead. Now, you're probably wondering, are we really at zero? Has all the progress we've made over the last hundreds of thousands of years meant nothing at all? Well, things aren't that bad. Scientists have crunched the numbers, and what they found is that we're actually at a 0.72. So close. We're at a type 3/4. They estimate that in 100 to 200 years, we'll get to a level 1, but instead of waiting that long, let's take a trip forward in time and see what that feels like. Type 1 civilization. Humanity will also need things like quantum computing and artificial intelligence to produce unprecedented technological advances. The medical breakthroughs we uncover have us living in a world free of cancer. You could have bionic limbs, and your overall lifespan is much longer. Interplanetary travel is also a regular part of life in a Type 1. You might want a vacation on the moon or Mars. And those crazy floods, Category 6 hurricanes, and tsunamis of the 21st century, they're a thing of the past. With this new supercharged energy, we'll have the power to reduce a Category 6 hurricane to a Category 2, or make it go away completely. That asteroid that's hurtling toward Earth? Well, no worries, you just press a button and nuke it. Congratulations, you're no longer in danger of being wiped out by natural disasters. It's safe to say that living in a Type 1 civilization would be life-changing. And that's not all. The way we communicate would be incredibly different. English has now become the unifying means of communication around the world. The internet has connected everybody on Earth, and we now have a single global currency for international commerce. And you're part of a more tolerant society, guided by science and reason, more unified as a single planet. Life on Earth is great, but the colonies on Mars and the Moon have whet your appetite. You're itching to explore the rest of the solar system. Well, what's stopping you? You just need a little more energy. Type 2 civilization. A Type 2 civilization is defined as one that's able to harness all the energy from its star. For you, that's the sun. How long will it take humanity to reach this point? Well, if you're around long enough to see this happen, it'll be a few thousand years. You're now harvesting all the possible energy from the sun. To do this, you've built a Dyson sphere around the sun. Or maybe you've built a Dyson swarm, a megasystem of smaller structures that orbit the sun, gathering its energy. Now, whether it's a sphere or a swarm, this megastructure collecting sunlight and radiating out this energy creates a distinctive signature in space, the signature of a Type 2 civilization. Now, this could be detected by other advanced civilizations looking for signs of life. Who knows? You might finally get a call from those elusive aliens. You're now part of a true multi-planetary society. Using the enormous amount of energy harvested from the sun, you make other planets and moons in our solar system habitable. Over a period of thousands of years, there are now fully functioning Type 2 colonies on Mars and our moon. Also on Venus, Europa, and Titan. Using advanced genetic engineering, we've modified our bodies to quickly adapt to different conditions on different planets, and to modify extreme conditions on other planets using weather engineering techniques. That poisonous gas on Venus, well, you get rid of it, and you'll mine other planets and asteroids in our solar system for their natural resources. I hear Jupiter is a great source of hydrogen. Now that you're free from the danger of being wiped out by catastrophic natural disasters on Earth, you're feeling invincible. Is there anything to worry about? Well, unfortunately, yes, you can still be wiped out by a cosmic scale disaster. For instance, a supernova explosion. It's the last stage of a dying star. If a supernova's blast wave strikes a dense cloud of gas around it, enormous amounts of X-rays could be produced, and these could damage the atmospheres of planets up to 160 light years away. An event like this could wipe out colonies on Earth and nearby planets. But come on, after so much progress, humanity isn't going to let some pesky space bombs wipe us out. To make sure that life sticks around, we're going to have to level up and inhabit more than one star system. So now you've got a new quest. You need to harness more energy, enough to avert disasters on a cosmic scale. It's time to become a Type 3 civilization. If you can level up to a 3, you'll ensure that human beings become immortal. But you've run up against a problem. Stars in our galaxy are as far as 100,000 light years away, and you can't travel faster than the speed of light. Type 3 civilization. Okay, it's another 100,000 to 1 million years later. Welcome to humanity as a Type 3 civilization. You're now harnessing the energy of all the stars in our galaxy. But wait a minute, how did you get to stars so far away? And how did you choose which stars to go to? Well, first, humanity figured out how to achieve velocities close to light speed. Sci-fi tech like ramjet fusion and photonic engines are all in your toolbox. Next, you manufactured trillions of von Neumann probes. These are robots that can land on distant star systems, duplicate themselves, and repeat the process. Like ripples spreading out from the center of the pond, they expand out in our galaxy, landing on and analyzing all the stars. They'll figure out which ones are ripe for harvesting energy. Now, once the viable stars are identified, you send out a seamless Dyson swarm to surround them. Humanity is now the master of the Milky Way galaxy. You'll live on any number of countless planets engineered to your liking. You'll command the energy of billions of stars to do your bidding. Also, between the transition from Type 2 to Type 3, your body will have evolved even further. You'll be a cyberborg, a super intelligent being with the capabilities of AI fused with your biology. Genetic engineering techniques will replace clunky implants and lab-grown organs. You'll be able to regenerate worn-out limbs and other body parts. And as your bones wear out, your genome will be programmed to repair the skeletal wear and tear. You're not a vampire, but you'll effectively live forever. With life thriving in multiple far-flung galaxies, neither cosmic nor natural disasters can wipe out human civilization. You can avoid being hit by a supernova explosion by altering its path. Even if our solar system gets hit by one of these, human life will continue in other planetary systems in the galaxy. Congratulations! You're now part of an immortal civilization. But the Milky Way isn't enough for you. You're ready to explore the other galaxies in our universe. Type 4 civilization. Welcome to a Type 4 civilization. As part of a Type 4, you're able to harness the power and resources of all the galaxies in our universe. Now, we should also mention that going past the initial 3 types of civilizations is beyond the Kardashev scale that was developed, and a lot of the theories about these extra civilizations lean more towards science fiction than actual backed up research. Nonetheless, they're still a lot of fun to speculate about, so let's get into these advanced and at times ridiculous civilizations. The technological capabilities of human beings at this stage are so advanced that it can be hard to even wrap your brain around them. In a Type 4 civilization, humanity has mapped out the entire universe, including all the galaxies and clusters inside it. You now have a deep understanding of every planet, galaxy, and star in the universe, the ones that are worth exploring and the others that are just massive rocks floating about. And with this level of knowledge, you'll come across other civilizations. Some of these are still in their embryonic stages, while others will be a little further along. Some might even be on a path toward annihilation, either because of their internal struggles or natural phenomena. Maybe, like any alien species that may be in existence today, you'll need to make decisions about whether or not to contact these earlier stage civilizations. You develop a set of intervention principles. Observing these civilizations becomes a fascinating exercise. You compare their progress with the history of Earth. But there's one pressing thing that keeps you up at night. Eventually, your universe, the only one you've ever known, will die. And with that, humanity will die out. To solve this, you aim your sights toward becoming a Type 5 civilization. You're ready to discover something even greater. Type 5 civilization. Welcome to the Type 5 civilization. Many doubted that humans could ever go beyond the edges of our known universe, but you've arrived at an even greater level of sophistication. You now control and harvest the energy from stars across multiple galaxies in multiple universes. How did you achieve this? A group of humans in the Level 4 civilization refused to let the human race die out with our original universe. Using technologies that I can't even explain here because they're so far beyond our 21st century comprehension, they helped humanity make the leap from single universes to the multiverse. But as humanity will soon find out, this is just the start. Type 6 civilization. Welcome to a Type 6 civilization. As a civilization, you can now pretty much control everything. You've uncovered the full set of universes that exist, and you understand their structure. In other words, you understand the omniverse. With these far-reaching abilities, you now see multiple timelines play out simultaneously. You think back to Earth's timeline, and you can't wrap your head around a time when humanity's level of knowledge was so minuscule. You thought ChatGPT and VR headsets were as far as humanity would go. Well, look at you now. For a while now, all your basic needs have been taken care of. Armies of robots grow and prepare food and construct shelters on planets of your choosing. Your bodies are cyberhuman, living for as long as you choose. So now, the only question facing humanity is the age-old one. What will make us happy? Maybe it's power, maybe creativity, entertainment, or the further pursuit of technological advancement. A governing body oversees the omniverse. Human-AI hybrid leaders follow a broad set of guidelines to maximize the good for all. With your ability to take on any form, you experiment with your appearance. Maybe you have a wolfish grin, or maybe you're covered with fur like a kitty. Some human beings will experiment as living as bursts of energy. Either way, you can assume any appearance you like, but this is still not enough. Humans want to create more. A class of creative technologists bids for the opportunity to create new universes when old ones die out. Within these, they create and play with the new civilizations. These new universes push the boundary of space-time. Civilization starts to place some regulatory guardrails around this as the construction of new universes is in an early stage. Type 7 civilization. You've now reached an unimaginable level of progress. The guardrails of level 6 are off. You can create, alter, and destroy infinite sets of universes, giving you complete control of the omniverse. Multiple timelines across multiple universes exist simultaneously. You can see the past, present, and future all at once. Humanity splits into two broad groups: hedonists, who continue to value optimized human forms and seek lives of pleasure, and achievers, who crave power and push the boundaries of technological creation. Did I say two groups? There's a third, which exists as pure energy. The new being you've transformed into exists in the form of higher consciousness. You've transcended all emotional states, and you're existing in a place beyond both happiness and suffering. You've reached a truly enlightened form. As pure energy, you're at one with every other human being, and you're at one with the omniverse. Okay, some pretty mind-boggling stuff. Now, this is what would happen if we went forward. But what if we went back, all the way back, to the start of the universe? Well, that sounds like a story for another What If. On July 13th, 2024, Donald Trump escaped an attempt on his life. He managed to turn his head at just the right angle so that a bullet shot in his direction grazed his ear rather than hitting him in the head. But what would happen if he didn't turn his head? What if Donald Trump was assassinated that day? Who would replace him? And could this lead to an American Civil War? In this video, we're going to go through multiple scenarios on what would happen if Donald Trump got assassinated. The first one we'll look at is if he actually got shot on July 13th. Now, I need to be clear that at the time of this recording, the assassination attempt is still being investigated, so some details may change, but what we do know is that the shooter came incredibly close. Another thing that I want to make clear is that I don't wish ill will toward anyone. If you're new to the channel, you should know that we often look at news stories and give our hypothetical take on it. That's all that this is. In Butler, Pennsylvania, on July 13th, the assassin shot from 140 meters away. Trump had just turned his head a couple of centimeters. If he hadn't have done this, it's very likely that he would have been killed by the bullet. Instead, the shot grazed his ear. If he hadn't been so lucky, we'd be looking at a completely different world today. Donald Trump would be dead. So, what would happen next? One of the most important things that would need to be figured out would be who would take the mantle of the Republican presidential nominee. It all depends on when this happens. The answer can change. If it were before the Republican National Convention or after. So, in the case of the July 13th assassination attempt, things would get a little more complicated. Since this event happened right before the Republican National Convention, which was set for July 15th, the delegates involved in selecting the Republican presidential nominee would have to move incredibly fast. With little time in between the shooting and the convention, the nominee would likely be decided on the convention floor that night. It would be incredibly messy and frantic. There'd be backroom deals and public speeches from the hopeful nominees. Now, since Trump had no strong opposition during the primaries, almost everyone could be considered. It would be like going back to square one. Even people who didn't run in the primaries could be nominated. This would be a night full of bids for power, and whoever's left standing would be the Republican nominee, who would then run for president. Now, there are some other scenarios that we'll get into in a bit, but what might happen outside of politics? Well, the answer to that is a lot more unknown and potentially terrifying. Donald Trump was seen yelling "fight" after he got shot, and there's a good chance his supporters would do just that. Now, we're not saying everyone, but the extreme fringe of his base might possibly engage. Just look what happened on January 6th, 2021. Trump supporters stormed the United States Capitol building. This was after their emotions were stoked by talk about a stolen election, a claim that was proven to be false. So, what would happen if their leader was assassinated? Well, they'd likely be looking for someone to blame, potentially a group of people or the opposing party. Donald Trump has incredibly passionate supporters, more passionate than what we've seen from almost any other political figure in the past. There's a good chance there could be outbursts of violence and civil unrest. Hopefully, this violence would be contained to small pockets of the country and not become a full-on civil war. With Biden still being president and commander-in-chief, he's in control of the military. If things got out of hand, hopefully they'd be able to put a stop to it. And hopefully no bigger militias would form either. Now, even without any violence, Trump would be idolized even more than he is today. Supporters would make him a martyr. And if some people on the left were happy that this happened, this would create an even bigger political divide across the country. The new Republican nominee would certainly use this as fuel to energize voters, turning him or her into an even stronger candidate. And more Trump supporters might be inspired to vote in the election now, even without him in the race. But what if Trump wasn't dead, but incapacitated? Well, technically the rules and laws that are in place would still apply, but there could be more nuance. If there's a chance Trump comes back and he's healthy, then the party would likely debate whether or not he could continue as the nominee. They'd also consider if he'd be in good enough shape to be sworn in if he potentially became president. Now, the story is a little bit different if the assassination attempt happened after the RNC on July 15th. Donald Trump would be elected as their nominee, so what would happen if he were to die before the election? Well, you might think that his running mate would be automatically elevated, so his current choice for vice president, J.D. Vance, would become the presidential nominee, but that's not the case. The nominee for president would still be voted upon by the Republican Party. They might go back to square one and reconvene the National Convention, or they might just select a new candidate. There's a good chance that Trump's running mate would become the presidential nominee, but it's not a guarantee. Other party members might want to get into the mix. Now, the same rules would apply if Trump won the election on November 5th. That would make him the president-elect until Inauguration Day on January 20th. If he were to die between those dates, the vice president-elect doesn't automatically become president. Since Trump wouldn't officially be sworn in, the 25th Amendment, which allows the vice president to become president if the current one dies, wouldn't be applicable. Now, this got me thinking, could anything like this potentially delay the election? Well, technically it could, but it's incredibly unlikely. Election day is set by federal law, and it's November 5th. In order for this to change, it would need to be voted on in the House of Representatives and in the Senate. The president would need to sign off as well, but this can only happen if both parties are in agreement, which seems unlikely, especially given the political divide gripping the United States. Also, this would only delay the election by a couple of weeks. As the Constitution states, a president needs to be sworn in by January 20th of the following year. Failing that, there would be no president and things could get really ugly. Now, this is how the election would be handled, which boils down to a lot of bureaucracy and systems we already have in place. What happens next could be extreme civil unrest, violence, anger, a potential civil war. It's safe to say this would be a scary time for America, for a number of reasons. On the other hand, maybe a violent act like this might inspire Americans to put down their weapons and come together. But considering the political division, that seems unlikely. Now, this is not a fun hypothetical scenario. Regardless of where you stand on the political spectrum, it would be a scary time for Americans and for people around the world. Let's just hope this assassination attempt doesn't lead to any further violent acts. I know I don't want to end up in a World War III. Imagine a world where the cities we know are underwater, and what used to be the ocean is now a barren wasteland. This is a world where every bit of water and land have suddenly switched places. Cities like New York and Paris would find themselves underwater. Tsunamis would come rushing into the cities, destroying everything. And if you're on a boat, you'd find yourself falling down into a dry ocean bed. The Amazon rainforest would be flooded and ancient diseases would come back to life. Which species of animals and plants would fare the best? Is there any way humans could survive this? And what would our new Earth look like? This is What If, and here's what would happen if water and land suddenly switched places. One of the more unexpected changes we'd see in this scenario would be significant climate change. This would be because of changing weather patterns and changing ocean currents. And because this dramatic change is happening overnight, we won't have time to prepare for it. But what if we knew this massive switch was coming ahead of time? Would there be anything we could do to stop it? Well, to answer that, let's take a look at our own climate issues that we're dealing with here on Earth right now. Climate change is causing global sea levels to rise at an alarming rate, leaving some of the world's biggest cities like London and Bangkok facing significant threats within a few decades if we don't do anything to stop it. With this much advance notice, well, you'd think everyone would be taking action to prevent this grim future, but as we all know, that's not the case. Some people won't believe or care about climate change until they're faced with an extreme situation like the one we're talking about today. But
Many people do want to help and make a difference, they just don't know how. Well, I might have just the solution. Say hello to Solar Slice, the startup company making it easy for you to make a real difference in the fight against climate change. Solar Slice lets you directly fund large-scale solar farms. With their app, you can track your energy production and carbon savings and even earn rewards to further support other climate initiatives. Here's how it works. First, you sponsor a slice of their large-scale solar farm, adding 50 watts of clean energy to the grid and reducing harmful emissions. Then, you can use their app to track your impact with real-time data on your slice's energy production and carbon savings. You earn eco points as your slices generate clean energy, points you can use to buy more slices, plant more trees, or fund more meaningful initiatives. And if you want to expand your impact even further, you can share your progress with others. Create group initiatives with friends, or send solar slices as eco-conscious gifts. To learn more, visit solarslice.com. You'll find a link to their Kickstarter campaign, which will help fund the construction of their first solar farm and development of their app. With the help of Solar Slice, we've got a chance to prevent a future where our cities are swallowed by rising seas. The people in our story, on the other hand, might not be so lucky. Okay, it's safe to say that water and land switching places would be the start of a new mass extinction. Your cities, towns, and any bit of dry land are now covered with water. Water now covers 21% of the globe, and land covers the other 79%. That means we'll have new oceans. We've now got the North American Ocean, the South American Ocean, and the European, African, and Asian oceans, all connected by narrow channels of water. And a new super large continent. In cities, people might have to run into skyscrapers to save themselves from drowning. They'll be looking outside, wondering when the waters are going to recede. Unfortunately, the answer is never. Because in our new world, water is here to stay on the old land. In this scenario, there would be two kinds of unlucky people. First, the ones who were outside on dry land and couldn't swim, they would have drowned immediately. The second group are the ones who lived far away from any kind of water, because now they'd be surrounded by water with no ability to get to land, unless they had a boat stored somewhere. Maybe you'd be one of the lucky ones. If you lived in a coastal city, say like New York, the Hudson River would now be bone dry. Maybe you'd grab a tire inner tube and put on your swimsuit and a backpack and swim out to the dry riverbed. Now, what about the animals? Well, unfortunately, marine life would be toast, or soggy toast. If all the water suddenly disappeared from lakes, rivers, and oceans, fish would be left gasping for air and would die almost instantly. Riverbeds and dried up oceans would be piled up with the carcasses of dead marine animals. No more whales, sharks, or any kind of fish. Say goodbye to sushi. Now, on the bright side, looking at this new world of ocean floors might be a fascinating experience. After all, maps of oceans here on Earth are less detailed than maps we've made of Mars. Scientists find 2,300 new ocean species every year. If we didn't have the water to stop us, we'd find hundreds of thousands of new species. Unfortunately, they'd all be dead. And animals in forests might have it even worse. Instead of a swift death, they might be left to suffer. Big cats like tigers and lions forced to climb up into trees. They might find themselves sharing the canopy with apes. Other animals like zebras and giraffes would be carried away by the current and drown. So, some of our land animals would survive and others would go extinct. But regardless of who makes it out alive, ecosystems would be savagely altered. But there are two species that would do particularly well in this scenario. The first are reptiles. Crocodiles, turtles, alligators, they're used to living on both water and land. And as they generally hang out in water close to land, well, they won't have to crawl far to find a new habitat. It'll be right next door. The second group that'll do great is insects. 66 million years ago, when the Chicxulub impactor hit Earth and the planet was full of dead, decaying matter, insects had a feast. Count on a repeat of that scenario as insects jump on anything that's rotting. The bad news?
Well, with swarms of mosquitoes, diseases like malaria are likely to break out among humans. Now, besides insects swarming everywhere, the other major problem in our new switched world? Well, there's no electricity. With power plants submerged in water, there will be damage to electrical circuits that can't be repaired. Because the water's not going away, for the first time, you realize how dependent you are on energy. Heck, your 13th floor toilet won't flush anymore because water is pumped up to it using electricity. There's no television, and of course there's no internet. Many of the world's population would be gone from this catastrophe, but there is a lucky set of humans who survive this horror. They are the 40% of the world's population who live in coastal cities, or they might live next to a lake, which is now an island. They've somehow lived through the initial tsunami. Their land is now water, but they can make their way to safety. On the California coast, they scramble onto the new shore of Pacifica, the old Pacific Ocean. From New York, they doggy paddle to Atlantica, the old Atlantic Ocean. To get the world back to normal, everything will have to be built from the ground up. Homes, agriculture, transportation, the list is endless and challenging. Building any kind of new home will be hard without materials like wood or cement. But there is one thing we could use: trash. Yeah, it's estimated that there are over 5 trillion pieces of trash in our oceans. Once the water leaves the oceans, humans could get resourceful and use the leftover garbage to make structures to live in. Kinda gross, yeah, I know, but at least it's been washed. Most land plants now will be submerged in water and will die, which means no access to fresh fruits and vegetables. Without vitamin C, scurvy, the disease sailors used to get, will increase. What is available is huge amounts of fish that have just died. Now, smart foodies will get to work. They dry and salt the fish to preserve it for the future. Pickling will be the new trend. Access to fresh water will be very limited. The humans who survive will be in for a punishing time. Now, in the medium term, the big challenge for humans will come from a shift in our climate. Our vast oceans play a key role in moderating our temperature today. As they shrink to a quarter of the area they once were, Earth will get much, much hotter. Water absorbs a large amount of heat, but with the total water area reduced to 21% of Earth's surface, oceans won't absorb as much energy from the sun as they do today. There will also be less water to absorb carbon dioxide. With oceans absorbing less heat and with more carbon dioxide in our atmosphere, Earth will get pretty toasty. Also, today's ocean currents are able to distribute the heat that they absorb to different parts of the world. In this new geography, the paths these currents are able to take will have bottlenecks that will prevent the smooth flow of water. Look how narrow the new Latin American channel is. Less water surface also means less water vapor and less rainfall. In this new world, prepare yourself for dry, desert-like conditions. Your best chance for survival will be to live near the coast. Expensive coastal real estate, that's one thing that remains the same. Now, let's say an enterprising group of humans somehow survives this catastrophe. How will life evolve? Well, humans will become insect and reptile eaters, connoisseurs of pickled fish. But that'll be a tricky balance because with many of our previous weapons now lost underwater, hunting crocodiles won't be easy. And if humans wipe out the reptile population, that eliminates an important food source. Unfortunately, slower moving turtles will probably be quickly hunted into extinction. Reptiles that can retreat further into the new oceans, far away from humans, will have a better chance at survival. In general, smaller members of any surviving species will do better as they can get by with less food. Over millions of years, they'll evolve, and as Earth's food sources get reestablished, the species will become bigger again. Birds are also likely to survive, though with trees gone, nesting becomes a challenge. Maybe they'll build nests in the top floors of old skyscrapers. And don't forget, with the destruction of ocean plankton and all of our land-based plant life, over time, oxygen will settle at a new lower level equilibrium. Unless plants begin to grow again on both land and in water, this lower level of oxygen will cause all species to evolve in new ways. Mammals may have bigger red blood cells, bigger lungs, or smaller bodies to use their oxygen more efficiently. And insect sizes will decrease over time as less oxygen will be available to them. Now, of course, the big question is, will humans survive such a catastrophic event? Well, it's hard to say, but if we look back in time, human populations have rebounded from numbers as small as a few thousand, so yeah, it's possible. If humans do survive, we'll emerge stronger and hardier than ever before. We'll build a new civilization on what's now become a hot brown marble. Hey, who knows, maybe even one day we'll become an advanced level 7 civilization. Humans merging with AI, the ability to control the weather, reinstating extinct species. These are just a few of the things that will happen in the next 100 years. Hop in our time machine and get ready for a wild ride as we travel decade by decade, exploring what humanity will look like in terms of technology, space exploration, and more. 2025 to 2035. In just the next 10 years, we're going to see some incredible progress in terms of space travel. SpaceX will be sending humans to the moon. The first step will be an uncrewed demo mission, but soon after that, SpaceX will launch the Artemis mission, allowing humans to set foot on the moon once again. And if you're wondering about getting to Mars, well, that's going to take a little bit longer. Stick around and we'll tell you when. But what else is going to happen to Earth in this time frame? Well, we'll fight a deadly killer, pancreatic cancer, with a new vaccine. It's based in mRNA technology, the same technology we used for the COVID vaccine. The first step to fighting this cancer will be surgery, but the vaccine will help prevent it from coming back. Vaccination will drive the body to produce protective T cells. These will recognize any new cancer cells and wipe them out. Now, while we're saving lives from cancer, humans will still be facing threats from climate change. One casualty of our climate crisis will be Bangkok, a city of 10 million people. Unfortunately, its soft, loamy ground is sinking lower and lower, 10 centimeters a year. The pumping of groundwater is pulling the city down. Now, at the same time, global warming is causing the oceans to rise. This beautiful city will see a terrible and devastating flood within the next decade. In the most extreme scenario, 96% of the city would be below sea level by the year 2030. Maybe a barrier at the mouth of the Chao Phraya River would help a little, but flooding can't be held off forever. For cities that don't get flooded with water, well, they'll see a big shift on the roads. Self-driving cars will finally deliver on their promise to dominate in the next decade. Unfortunately, they'll probably be tied to a subscription service, so get ready to pay an extra $10 a month for car flicks. And if you do choose to drive your own car, it'll be kind of like a hobby, like flying a kite or something. But this is just the start of our future. We've got 90 more years to cover. Hop back in the time machine and let's head over to the next decade. 2035 to 2044. Okay, let's check in on how space exploration is progressing. We'll finally get to surf the hydrocarbon seas of Titan, Saturn's largest moon. We'll send a submarine into space, getting it to land on another moon and plunge into the ocean there. By studying Titan, we'll learn new and fascinating things about how life began on Earth. Titan has an internal liquid water ocean, which could contain the building blocks to alien or human life. It also has dunes that are rich in carbon and nitrogen compounds. Who knows what new life forms we might find out there? But that's not all. This is also the decade when we finally have a crew of humans landing on Mars. We'll get a better understanding on how to deal with the many challenges of this mission by around 2040. And we'll find solutions for all sorts of things we previously thought weren't doable. Things like how to minimize the effects of radiation during the trip to Mars and how to produce oxygen from the Martian atmosphere. We'll also solve the problem of having fresh food and water on the planet. Not to mention, we'd be building pressurized, radiation-resistant shelters that will allow us to live on the red planet. And it's a good thing we'll be further along in our exploration of other worlds too, because things might be getting a little too hot to handle here on Earth. By 2035, our planet will be 1.5 degrees Celsius warmer. Lemurs will be going extinct, and those cute koalas in Australia, say goodbye to them too. Extreme heat waves will be common in the US. Worse than that, high-intensity hurricane winds are breaking and redefining the hurricane scale. Category 6 hurricanes with sustained winds over 125 kilometers per second may be pretty infrequent today. We've only seen 5 of these since 2013, but in 20 years, they'll hit the Gulf Coast cities so frequently that people will start emptying out of the coastal cities. Goodbye Houston, Galveston, Baton Rouge. Now, weather won't be the only thing that's changing. Our demographics will be shifting too. By around 2044, white people will be a minority population in the US. And if your reaction to this is, meh, so what? Well, you're in good company. A majority of Americans feel this is neither a good nor a bad thing for society. 2045 to 2054. Climate news will get worse during the 10 years between 2045 and 2055. Temperatures will be 2 degrees Celsius above pre-industrial levels. That's a lot. This will have important consequences for the trillion-odd species on Earth right now. Many will be victims of the 6th extinction event. In this decade, 40 to 50% of our current species could go extinct. Among them are the African forest elephants, Amur leopards, and the Yangtze finless dolphins. Populations of these creatures are already dwindling today, so unless there's a drastic change in our warming climate, poaching, and forest loss, well, animals like these are on their way out. The Dead Sea, a unique natural phenomenon with a salt content 10 times higher than the oceans, is also at risk. Sadly, these salty waters will slowly evaporate due to the immense heat. Currently, in the Dead Sea, evaporation is causing water levels to drop an incredible 1.2 meters each year. During this decade, we'll finally kiss it goodbye. Now, with the devastating effects of global warming, there will be more pressure to innovate. We'll see a major new development in energy, one that will crack the code to commercializing fusion power. This is the process that smashes 2 hydrogen atoms together to form helium, and in the process, release a lot of energy. Today, we don't know how to do this cheaply, but 20 years down the line, we'll figure out how to get the cost down. This will be the beginning of the end of carbon emissions. Something else we emitted into the air decades ago might also finally have an update. In 1999, Ukraine sent a message named Cosmic Call 1 into space. In 2051, this message will reach its destination, Gliese 777, a yellow subgiant star 52 light years away. Maybe we'll get a call back from the aliens on their iPhone 6751. 2055 to 2064. In 2058, the Beatles' music catalog will enter the public domain. I'd play some of it for you right now, but we get a copyright strike. But not 50 years from now. Also in this decade, we'll have established a permanent presence on Mars. Probably not the colony of 1 million people that Elon Musk has projected, but definitely a base camp and the start of a Martian future. Back on Earth, we'll finally have umbrellas that don't get wet in the rain. Not super exciting at first glance, but it means we'll be masters of nanotechnology. We'll be able to incorporate tiny structures into fabrics, which do amazing things. In the umbrellas, we'll use what's called the lotus effect, where the nanoparticles repel water. Nanoparticles in our clothing could dissolve dirt and kill microbes, so we never have to wash our clothing either. I'd be happy if I never had to do laundry ever again, but forget about laundry. There's another thing we'll be rid of. By 2060, we'll eliminate coal and oil from our energy system. Solar and wind power will be widely incorporated into society, and we'll be making even bigger strides in fusion power. More on that in a minute. 2065 to 2074. Now, if you think nanotech clothing is pretty cool, well, in the next decade, we'll be mastering pico technology. This is 1,000 times smaller than nanotech. Scientists will be manipulating the energy states within electrons. This will change the structures and properties of individual atoms. From this, new types of matter will emerge. Who knows, maybe we'll be building entirely new kinds of chips or supercomputers using this new technology. Now, if you're watching this and you think you might have a hard time making it to 2065, well, you're in luck, because by this decade, technology in the medical field will have progressed so far that we'll be able to print new body parts in 3D. Yeah, we'll be rejuvenating ourselves with stem cells, and gene editing will be able to cure diseases. Through a combination of these and other methods, the medical field will be helping people live years, maybe decades longer. 2075 to 2084. Okay, by the late 2070s, the transition to clean energy will be complete. Humanity will be carbon neutral across the globe, and the last of natural gas power will be phased out. Electric cars will be everywhere. The gas vehicles we ride around in today will be considered vintage toys. And with the advances made in nanotechnology, our solar cells, which convert the sun's energy into electricity, will be super efficient. Now, technology will optimize our human bodies too. Artificial organs, bionic eyes and ears for supervision and hearing, and implants to enhance intelligence. Humans 2.0 will be vastly superior to what we are today. More intelligent, by design. This is the decade we'll also find a new way to launch ourselves into space. We'll look back at today and think, gosh, space rockets? That was so 2024. Instead, we'll have a space elevator. This will require a cable that runs from the ground up through the atmosphere all the way to a satellite that orbits in sync with the Earth's rotation. That cable will have to be made of some special material, maybe diamond nanothreads. 2085 to 2094. Now, despite our efforts to curb climate change, temperatures will keep rising due to the carbon dioxide that's already been baked into the atmosphere from prior decades. Many parts of the world won't have snow anymore. We might have to say goodbye to the Winter Olympics, skiing, and ice hockey. But that might be the least of our worries. With our ice continuing to melt, polar bears could face extinction. Their numbers will have already dropped by 70% between 2000 and 2050. The few remaining bears in the interior Arctic will be struggling to stay alive. But having figured out the de-extinction processes, we'll know how to bring the polar bears back in the future. We've already created embryos of some extinct animals using genome mapping and gene editing. In the next half century, scientists might figure out how to implant these embryos into closely related species, giving us a path out of extinction. For the first time in Earth's history, we may be able to turn back the clock. With global temperatures still rising, by 2090, Western Antarctica will be as warm as today's Alaska or Iceland. If we travel even further ahead in time, the new landscape would be unrecognizable. Many of the largest Antarctic ice sheets will have melted away, and human settlements will be on the rise, with new towns and urban infrastructure built on the Antarctic soil. 2095 to 2104. The landscape will also be different for the Atlantic Ocean. In the second half of the 21st century, a vast network of wind farms will be springing up in this part of the world. By the end of the century, they'll transform our methods of power generation. But they'll have another interesting capability, allowing us to control and moderate the weather. Even as hurricanes intensify and break all records, wind turbines can absorb the energy, reducing hurricanes from a level 5 to a level 1. Some of the Gulf cities that emptied out may start to repopulate. Over 80% of the Amazon rainforest will disappear by the end of the century. Logging, fires, farming, and industry will destroy this valuable resource. As a result, many plant and animal species that lived in these forests will have gone extinct, and indigenous peoples who made their home here may be wiped out. Rapid globalization and interconnectedness will also cause the extinction of our languages. In the late 20th century, there were over 7,000 languages worldwide, but by the time we get to the year 2100, we'll be down to just 3 languages: English, Mandarin, and Spanish. 2105 to 2115. Okay, if you're able to live until the 2100s, genetic engineering will be able to transform your body in new and unusual ways. Early in the 22nd century, we might be incorporating a key element of plants into our human cells, giving some of us fantastic new capabilities. Which element? Chloroplasts, where photosynthesis takes place. This would enable us to take in the sun's energy and carbon dioxide to produce our own sugars. It'll be a whole new way of feeding ourselves. And humans could also find a way to live forever. The technology to upload our minds, including our complete memories, into a computer will be perfected. The world might divide into those who want to live forever inside a computer and those who don't. 2115 to 2124. By the dawn of the 22nd century, AI will be an integral part of all society. Humans merged with AI will possess vastly superior cognitive capabilities. These human-AI hybrids will combine the emotional intelligence of humans with the intellectual and analytical superpowers of AI. This could create wars between humans who have merged with AI and those who have not. We'll now have permanent settlements on the Moon and Mars. We'll have explored the outer reaches of our solar system, sending missions to the gas giants, the Kuiper Belt, and beyond. We'll be mining asteroids for minerals and metals. Couples getting married will argue about whether the destination wedding will take place on the Moon or on the Red Planet. Well, maybe they'll marry on one and honeymoon on the other. The next 100 years will see terrible lows and amazing highs. With massive climactic shifts, Earth will transform, cities will be underwater, and many species will go extinct. Even as this is happening, humans will merge with AI to become exceptional transhuman beings. We'll conquer space. Eventually, we'll become carbon neutral and then find ways to tame the weather. And in the distant future, we'll apply our intelligence to repopulate the Earth with the species we wiped out. Over the next 1,000 years, humanity might evolve to survive a car crash. Maybe we'll adapt to have text claws and a tech neck due to our excessive smartphone usage. Or maybe we'll finally fuse with technology. In this episode, we're going to look at what scientists have theorized might be the next stage of human evolution and find out what the perfect human might look like in the future. For our first future human, let's take a look at Text Claw Mindy. She's got a hunched back, a hand with a permanently molded text claw, and an unnaturally bent smartphone elbow. In 1,000 years, scientists are predicting this might be our reality. But why? Well, the humans who are alive today are wildly different from the humans that were alive thousands or millions of years ago. We're no longer swinging on branches, no longer running away from tigers or fighting them. Today's humans are usually sitting down, eyes glued to a computer all day. This strains your neck and throws your spine out of balance. Humans were built to stand up straight, not be couch potatoes. But maybe future humans will evolve to have a hunchback that would give us an evolutionary advantage in computer work. And since we're always on our phones, we might develop traits like text claw and smartphone elbow. Maybe these traits will pass on to the next generation, creating an army of Mindy-like humans obsessed with their phones. as if we're not already. We've already started blending our bodies with technology, but one day it might be hard to tell where the human ends and the tech begins. I'm not talking about the stereotypical cyborgs you see in movies. I'm talking about something much deeper. What's kind of wacky is how, in this kind of tech-heavy world, your brain might evolve. Well, let's start with your skull. Studies have shown that radio frequency radiation from smartphones might be damaging your brain. It might make your memory worse or affect your cognitive skills. So Mindy over here was given a thicker skull. This gives her brain protection from potential radiation via phones. And bad news for the brain itself, it's gonna get smaller. Yeah, I know this doesn't sound great. I can barely remember where I put my keys, but this is just gonna make it worse. Brains today are already much smaller than they used to be. Before the dawn of civilization, human brains had to do a lot more work. Without advanced weapons, we had to use our brains to save ourselves from predators. Without farming, we had to remember where all the good fruit trees were. Well, today, technology does a lot of our thinking for us. We've got calculators, Google Maps, and now AI to do our programming or our homework. Our life today is simpler and safer. With AI, this trend of not having to think as much will continue in the future. But more on that in a bit. What about our overall size? Well, this is a bit of a toss-up because of two opposing trends. On the one hand, life is no longer about the survival of the fittest in terms of size. Humans don't have to be big and strong to beat up tigers or other humans to see another day. It's more important that they're financially savvy to survive. While the threat from predators is reduced, that doesn't mean humans are totally safe. We've got new predators to worry about, ones made by man. Climate change, ongoing wars, a potential nuclear apocalypse, and these threats are likely to continue. So how could humanity evolve in response? Well, surviving climate change might happen two different ways. The first may be to amass wealth and to use that wealth to protect from the effects of climate change. Maybe these humans will be the hunchback computer type with the text claw. They'll be running for their underground bunkers stocked with caviar and sparkling water and shorting stocks. All while tsunamis rage or radiation pulverizes everything. The second group are people who aren't as lucky to hang out in bunkers. They might evolve physical characteristics that help them survive. To see what these may be, let's take a little detour and look at this weird-looking guy. Crash-Proof Graham. Meet Crash-Proof Graham. He's been built by scientists to survive a unique type of devastation, a car crash. Come to think of it, getting caught in really bad weather is kind of like being in a car crash. Yeah, a tornado can throw you around and injure you quite badly. With climate change, the frequency of devastating hurricanes, tornadoes, and other extreme weather events is on the rise. Without that underground bunker, we can look to Graham as a potential way humans could evolve to survive. Let's take a look at his brain. Graham is able to survive devastating impacts because his brain is encased in a bigger, thicker skull, one with more fluid around it to cushion the brain, and more ligaments to hold it in place. It sounds like this would allow the brain to survive all sorts of things: car crashes, tornadoes, maybe even earthquakes. Then we get to the neck. This is a particularly vulnerable part of the body. If your head whips back and forth, there's a lot of pressure on the vertebrae in your neck and they can break. So a short, thick neck, or even better, no neck at all, might be a survival advantage. Graham also has stronger ribs that could help his body survive a high-impact crash, plus a thick layer of tough skin that would protect against cuts and injuries. And then there's a really weird trait that might create a unique evolutionary advantage: joints that bend in multiple directions. Today, our knee and elbow joints only fold in one direction, so impact from the wrong direction can make them break. If we took these flexible joints from Graham, it could help us survive whatever's coming our way in the next 1,000 years. Of course, it may take longer than just 1,000 years for these traits to evolve, but maybe, given the rate at which the planet is warming, we'll start to evolve these survival traits much faster. I'm especially thinking about the billions of people in the world who will have to brave the elements as things get worse. The one difficulty that crash-proof Graham might have as evolution perfects his disaster-resistant body? He might have trouble getting a date. Okay, is there another version of future human who could evolve to be better than today's model? Maybe modern gene splicing techniques can help build a new perfect version of you, but one who's a little hotter than Texclaw Mindy and Crash-Proof Graham. Anatomically amazing Alice. Here's Alice. She's the brainchild of Dr. Alice Roberts, who came up with a new, better design for the human body, cleaning up the messy bits from what evolution gave us. Her perfect body would take the eyes from an octopus, allowing us to see better. The next fix would be our ears. When you're young, you hear pretty well, but as you age, tiny hair cells in your inner ears get worn out, so your hearing gets worse. Instead of trying to make those little cells regrow, we could just get bigger ears. You know, like a cat. These would be better at amplifying sound. And I gotta admit, they look pretty cool. Then there's the throat. Perfect Alice has two separate pipes, one for air and another for food. Fine by me. Okay, and now for something special that's got to do with babies. No, not that. The human pelvis evolved to support us properly while walking upright, but it definitely doesn't have room for one thing: large-headed babies, which is what humans tend to have. This makes childbirth pretty difficult, so I've heard. The perfect human body would borrow a trick from the kangaroo. How about a little pouch? This way we could give birth to smaller babies at a younger stage and have them mature in our pouch, just like marsupials do. Then there's our skin. If you're kind of fair-skinned like me, you can get sunburnt and be at risk of skin cancer. Yikes. One solution is to just go for darker skin, which doesn't burn as easily. But even cooler might be to borrow another trait from the octopus. It can change its skin color. Now with that trait, light-skinned people can keep their light color in winter and get darker in the summer for protection. Finally, the human leg could do with a fix. Yeah, they're slow and tough to move. Ostrich-like legs might be the solution. We make the lower leg less muscly and make the feet light so they're better equipped to run. The final touches are shorter, chimpanzee-like spines, which are less likely to get compressed as we age. But sorry, that means no slender waists for anyone. Hearts with more interlinked arteries so you never get a heart attack, and air sacs like what birds have rather than our lungs. Anatomically amazing Alice looks pretty cool. If scientists begin to splice some genes, we might just get to this point in the next 1,000 years. But wait a minute, with advances in biomedical research, we've already begun fusing technology with the human body. What are some of these modifications we're likely to see in the future? Transhumanic Tim. Meet Transhumanic Tim, whose body is part human, part machine. They're merged with technology so they can see better, hear better, remember more, run faster, fight disease better, and even more amazing, live forever. Maybe Tim will wear a modern hearing aid, which will not only amplify sounds that are far away, it can record sound and create white noise. Today, bionic eyes help blind people see. They're surgically implanted devices that improve sensitivity to light so that people can distinguish between shapes and tell the difference between a knife and a fork. But in future, these kinds of implants will help Transhumanic Tim see things they've never seen before. X-ray vision can become Tim's reality. Tomorrow's enhanced human might also have implanted devices that improve memory. In 1,000 years, maybe we'll all have that skill. Today, scientists are making prosthetic devices implanted in the brain that can decode how you store memories, then apply neurostimulation to help the person retrieve those memories later. As the technology gets better, we'll each have a built-in encyclopedia. And our ability to fight diseases will be better than ever. Not only will this help humans live longer, but potentially forever. Not living forever in your regular human body, but uploading your brain to a server. Now, this would be incredibly complex because of the sheer volume of information in our brains, but let's say we somehow crack that code. We managed to find a way to upload all of our information to some storage space. What's next? Assuming that humans 1,000 years from now aren't regenerating our limbs, where would our brains go? Would they sit in a computer? Or go into a new robotic body? That will be the last stage of transhumanic Tim, and it'll last forever. Now, all these evolutionary upgrades are pretty incredible, but can we do better? The perfect future human. Okay, now that we've learned a bit more about what the next 1,000 years will bring, it's time to build our own version of the perfect future human. Let's take the bits we like the best. Physically speaking, this human will be taller. Yeah, the challenges with climate change may favor smaller humans for a little while, but better nutrition and natural selection will push for greater height. I like the bigger eyes and feline ears from Alice. I'm not sure everyone needs X-ray vision, but maybe if you're going to med school, you get equipped with bionic eyes. Our future human definitely needs a thicker skull, protecting a smaller brain, but with much bigger brain power, because they're equipped with a memory-enhancing prosthetic that gives them that photographic memory. This makes school a breeze and puts Google Maps out of business. Plus, it has another advantage. Since we future humans will be able to remember a lot, we're not on the phone all the time, so no text claw for future human, and no hunched back. With massive tsunamis, storms, and tornadoes happening more frequently in the future, our future humans need to stay strong. So I'm going with the heavy-duty rib cage and the shorter spine, two features that will protect and age well. Thanks for that idea, Graham. As for the marsupial pouch, I'm thinking about that one. As brains shrink, well, maybe babies' heads will get smaller and regular childbirth will be easier. If not, I'm definitely including a pouch, so childbirth is not as painful as it is today. Both crash-proof Graham and anatomically amazing Alice had noted improvements with legs and feet, so our future humans will have those. Knees that bend any which way, slimmer ostrich-like calves, and lighter, springy feet. I'm also going with a set of multi-purpose nanobots that roam inside the future human body. They can decimate a tumor, reduce inflammation when they see it, and generally enhance the body's immune system. All right, our future human looks pretty cool, ready to take on the terrifying challenges of 3000 AD.
This is Io, one of the 4 largest moons of Jupiter. A terrifying, inhospitable world. It's got huge lakes of molten lava, bigger than an average city. There are hundreds of volcanic eruptions that could dwarf a skyscraper. Oh, and its surface is constantly ripped apart by the gravitational force of Jupiter itself. Yeah, Io is an...
You're sending me there, aren't you?
Hey, I'm not done with the introduction. Can you wait a second?
Oh yeah, sure, go ahead.
So, yeah, not a place that's likely to get a 5-star review on TripAdvisor. I mean, could you even spend 5 seconds on Io?
Here it comes.
Well, luckily, you don't need to, because we're sending our team member Chase to explore this fiery hellscape.
Sounds great. Fiery hellscape, almost certain death. What's not to like?
Before you worry about what's waiting for you on Io's surface, first you'd need to figure out how to get there. Thanks to Jupiter's elliptical orbit, the distance between it and Earth is constantly changing. Even when it's closest to us, Jupiter is still 588 million kilometers away. It took NASA's New Horizons spacecraft 1 year, 1 month, and 9 days to get there. And that's the fastest anyone, or more like anything, has ever made the trip.
Only?
1 year is nothing for this trip. And New Horizons was an interplanetary space probe that didn't carry any humans on board. With all the extra stuff like life support systems and food supplies weighing the ship down, this trip would take a lot longer. You'd be looking at 2.5 years or so. Well, unless you're traveling at light speed, in which case it would take a speedy 33 minutes.
Oh, okay, great. This ship travels at light speed, right, Rico?
Assumption incorrect.
I don't understand. Does it go at light speed?
Negative.
I'm not following you.
This ship does not travel at light speed.
No way I'm dying on this moon. So what if it's hot and volcanic and can crush me at any second? This time, I'm coming prepared. I know a place where I can get exactly the gear I need. This place is so epic, so awesome, only a few people know of it. Now we're talking. I got this fire proximity suit over here to get close to the volcanoes. This bad boy's good for up to 1,000 degrees.
I strongly advise against it. According to my calculations, fire proximity...
Yeah. Nobody asked you, Rico. Just make yourself useful and, like, I don't know, set a course to Io or something. Did you know that Jupiter has anywhere between 80 and 95 moons? You'd think there'd be a specific number, but no. Scientists are still counting them. Seems like they have a lot of time on their hands. Just like me. I'm gonna guess that's Io. Finally!
Correct. We arrived into the orbit of Io.
Cool. Yo everyone, finally made it to the orbit of Io. I am beyond stoked. What are we waiting for, Rico? Land this puppy.
Running pre-landing calculations.
Okay, well neither of those look promising.
Landing on Io would be tough. I mean, even if you got down to the surface in one piece, it won't be a very smooth landing. You see, Jupiter's magnetic field is extremely powerful, much more powerful than Earth's magnetic field. And Io is only 422,000 kilometers away from Jupiter. That means Jupiter's enormous magnetosphere constantly rubs Io, and not in a gentle way.
What the hell is that?
That's Io. Well, parts of it anyway. Every second, Jupiter strips off literally a ton of material from Io. All that material then follows Io in its orbit around Jupiter. Here, the gas giant charges Io's stripped particles with radiation and transforms this particle cloud into plasma. Scientists call this a plasma torus, but what it really is a cloud of intense radiation in the shape of a donut.
Sounds like my kind of donut. Some people like an old-fashioned glaze. Some people like a classic chocolate with sprinkles. Me, I prefer an intense cloud of radiation. Plasma torus. Rico, by the way, this fire proximity suit is resistant to radiation, right?
Negative.
I don't get it. What do you mean?
I mean no. Fire proximity suit is not suitable for environment with high radiation. Your chances of survival are 0.02%.
Great. What does Rico even stand for? Really encouraging, caring omnibot.
Encouraging starts with an E.
Shut up, starts with an S. Alright, Rico doesn't recommend me using this fire proximity suit like it's not good for radiation or something. But guess what? I only need to spend 5 seconds on Io to complete my mission. And this suit has gotten me killed. Like, too many times, okay? This time, I plan to survive.
Landing sequence initiated.
Well, good luck making it to that constantly changing surface. Io's orbit cuts right across Jupiter's magnetic lines of force, and that basically turns Io into one massive ball-shaped electric generator with a serious amount of lightning in its upper atmosphere.
Rico? This is crazy! I wish someone had shown me a simulation so I knew what to expect!
And so here you are, on the surface of Io, the most volcanically active world in our entire solar system. Yeah, you're gonna run into a lot of volcanoes, hundreds of them. And these volcanoes are extremely active. Many of them shoot fountains of lava, dozens of kilometers into the air.
This place sucks. Yikes, that was a rough landing. And what's up with all these volcanoes? I've never seen anything like it. Literally, I have never seen anything like this.
These are due to a constant gravitational pull. And it's not just because the biggest planet in the solar system happens to be right next door. Io's neighboring moons, Europa and Ganymede, are also pulling on it.
Guys, I landed on Io, but there was a problem. Not gonna lie, it wasn't a smooth landing, but Io has all these volcanoes and lava lakes everywhere. There's all these tidal forces pulling and pulling on this thing. The surface of the moon is constantly changing. So honestly, guys, get in the comments, but don't be too harsh on Rico for his awful calculations. Seriously, the worst trash bag calculations I've ever seen. Oh, Rico, you were here the whole time? Anyways, gotta change into my fire something suit. Get out there, gotta go fast. The ship is sinking.
Warning, temperature reading at 1,200 degrees Celsius.
Io is a cold moon with average surface temperatures of minus 130 degrees Celsius. But around its countless volcanoes, the temperature can get as high as 1,600 degrees Celsius. What you really need is a good space helmet, and make sure those air filtration systems are working. The atmosphere of Io is primarily made out of sulfur, which isn't great if you're a fan of breathing.
I do love breathing, but I also love this suit. It's so shiny. It's giving disco.
Feel like you could spend a lot more than 5 seconds here?
Yeah, looks like it.
What's this atmosphere made out of again?
Sulfur, the gas that is not recommended for breathing. It makes your voice deeper.
Yeah, the thing is, you can't survive more than a minute on this moon. Definitely not in that outfit. After just 30 seconds without proper protection from radiation and extreme temperatures, and without a good amount of oxygen to breathe, you'd lose consciousness. Your organs would shut down, one after another, and 1 or 2 minutes later, you'd be gone. Just like Chase over here.
Today, we're going to go on a journey 10 quintillion years into the future. A time where our universe will look and act completely different. Stars will have died out, black holes will form, Earth will be a distant memory. But what else will happen? Will humanity be able to survive this long? Before we get started, let's clear up how many years we're going into the future. What is 10 quintillion years anyway? Well, it's a 1 followed by 19 zeros. Yeah, it's pretty big. 10 billion billions. We can't even squeeze all those zeros onto your screen. But never mind that, we've got a lot of ground to cover. Let's start 1 billion years into the future, where something terrifying is happening. 1 billion years from today. In 1 billion years, Earth will look incredibly different. What was once our blue marble full of life is now a dull brown rock with no life to be seen.
Changes to our sun have killed off all life on Earth. The sun has been growing hotter and hotter, about 1 degree more every 100 million years, and the surface temperature of Earth is now 47 degrees Celsius. That's 117 Fahrenheit. This increase in heat first disrupted the carbon cycle. Plants died off, and then animals shortly thereafter. There might have been a little bit of life left in our oceans, but then it got hotter and the water evaporated. What was once a beautiful planet, teeming with life, is now a dry, dead rock. But what about us humans? Well, hopefully we made it out of Earth and built colonies somewhere else in the galaxy before the sun decided to kill us. But you wouldn't catch us living on Mars. Even that would be too dangerous with this hotter sun. We humans would need to be living much farther away. We'd need to set up shop in other galaxies within the Milky Way. Hopefully, within a billion years, humans have developed an efficient system of populating habitable planets. By this time, a populated Mars would be a distant memory. But it's possible that the outer planets in our solar system, or their moons, might become habitable for us for a little while. There's also another possibility. There may be a subset of humans who live on in the form of pure artificial intelligence. People who have uploaded their consciousness into machines and live virtually forever. But the machines that host them, well, they'd need to be powered by something, somewhere, so physical humans would still be around to set up these colonies that will keep our virtual humans going. But this is just the start of where our future is headed. Let's hop back in your time machine and go forward another few billion years. 10 billion years. Time for your next stop. 10 billion years into the future. As you're flying in your time machine, you notice that the solar system looks very, very different. The sun is now smaller. It's about the size of Earth. It's also white and much dimmer than before. Well, over the last 9 billion years, the sun burned all the hydrogen in its core. As its shell started burning, it became a red giant. Finally, with all of its fuel burned up and with it reaching an older stage in its life as a star, it became a white dwarf. That's what you're seeing now. During its red giant phase, the enormous energy given off by the sun caused its outer layers to expand, engulfing Mercury and probably Venus too. It looks like the Earth has been vaporized and is stripped down to its iron core. At this point, the sun will cool off for billions of years before it reaches its next stage, a black dwarf. More on that in a minute. As the sun was getting older and dying out, another big event was also happening. 2 massive galaxies merged with each other, creating an entirely new galaxy. You've got the Milky Way galaxy, which is the one we live in, and then our neighboring galaxy, Andromeda. Both galaxies are part of a shared space neighborhood containing 50 galaxies. These are called the local group. And due to gravitational forces, some were moving closer together. The Andromeda galaxy moved toward the Milky Way at 400 million kilometers per hour. If you stood in the middle as they merged, you'd probably feel like you were in the middle of a giant snow globe that had been shaken violently. Except instead of fluffy snow being thrown around, it's rocks, planets, and entire stars. This went on for millions of years. When these 2 galaxies were finally merged, they created what's known as the Milkomeda galaxy. Would stars have collided during this merger? Well, you might think so, but probably not, because of the vast distances between them. They're really far apart. We're talking hundreds of billions of kilometers. But what would happen to our solar system in this merger? Well, scientists have calculated that there's a 50% chance our solar system would be pushed far away from the galactic core, 3 times further away from where we are today. And there's a 12% chance our solar system would be completely ejected from this new galaxy. But by that point, we humans would no longer be living in our solar system. If we were still around, we'd have populated planets in a galaxy far, far away, and we'd definitely choose one that wasn't about to go through a merger. So say goodbye to the Milky Way galaxy and say hello to Milkomeda. All right, now it's time to check in and see what else is happening in our universe. 22 billion years. In 22 billion years, things start to get a little complicated. Something is going to happen that's known as the Big Rip. According to one theory, we're heading to a point in about 20 billion years where the universe is going to tear itself apart. This will be due to dark energy. Yeah, dark energy. Now, that's something physicists don't even completely understand, but they do know one thing. It's causing the universe to expand faster and faster. Keep this dark energy in mind, as we'll come back to it later. Now, if the Big Rip happens, galaxies that exist today in clusters will begin to stretch apart, and then all the objects within these galaxies will move away from each other. Star systems, planets, everything will accelerate away from one another, right down to their atoms, which would rip apart and dissolve, leading to the end of the universe. Scientists have found some evidence that we could be heading toward this demise, but it's not 100% certain. Good, I was getting a little nervous there. Okay, so for now, let's assume that our universe doesn't rip apart 20 billion years from now. What happens next? 100 trillion years from today. Even though the Big Rip may not happen, that doesn't mean our universe will be safe. Over these 100 trillion years, stars all across the universe will be dying out. Let's go back for a second to the Big Bang, when the universe began to form. 150 million years after that, stars were created. Now, since the formation of that first star to where you are now, new stars have been and still are forming all the time. The best way to see this is if you peer into these clouds of interstellar hydrogen gas that are everywhere in space. If you look at a dense area, you can see how it collapses in on itself and leads to the formation of a star. Over the 100 trillion years, you'll notice that stars are forming in all different sizes. The basic rule is the smaller the star, the longer it lives. Look at this star, which is just 8% the mass of our sun. It's just a little too small to get hydrogen fusion going, so it's a failed star, also known as a brown dwarf. And here's a bigger one, about 10 times as massive as our sun. It burns hotter, and it's blasting through its fuel very quickly, so in about 20 million years, it'll die out. And you already saw how our sun died after about 10 billion years, but the majority of stars you've seen are smaller than our sun. These are red dwarfs. They're about 8% to 50% the mass of our sun. They're a lot dimmer, but they also live longer, about 80 to 100 billion years. So during this time, you'll start to see a lot of these red dwarfs starting to die out. Then we've got the brown dwarfs. These are so dim that they're hard for you to see. They die in a mellow kind of way, getting cooler and cooler. As they cool, their temperature will drop to about 2,500 degrees Celsius, which is cooler than most stars. Finally, let's check out the end of this incredibly massive star. It's 8 times the size of our sun. Its core is collapsing into a massive explosion that creates a supernova. This gives rise to a neutron star, which is an incredibly dense and compact star. Or its death could result in a black hole. Over these 100 trillion years, you've just witnessed the stelliferous era. You've seen stars being born and dying, planets coming and going, and the merging of galaxies. Well, there's also another incredibly important thing that's been happening as our stars have been dying. You see, when stars die, they release various elements and materials out into space. This often leads to new stars forming, but not all the mass of a dying star gets released and available for new star formation. Because of this, the universe will slowly run out of raw materials in the form of hydrogen gas to make new stars. Could this spell the end of the universe? 10 quintillion years. Okay, welcome to your final stop, or almost final. It's
10 quintillion years into the future. Remember, that's 1 followed by 19 zeros. The Stelliferous era has ended, and we're in the early part of a new time called the Degenerate era. And no, that's not when a bunch of Redditors take over the universe. As you fly through the universe, it appears much dimmer than it did before. Once twinkling with bright stars, it's now a graveyard. This is a universe littered with the remnants of dead stars. White dwarfs, brown dwarfs, neutron stars, black holes. All the stars that have ever been born have given up their light and died. So, if star formation is over, what happens to humans? Even if we're living in other galaxies, we still need a solar system and a viable planet to live on. Well, one possibility is that we've given up our material bodies and we're existing entirely in the form of energy. Oh, that's cool. But there's another possibility involving a whole new universe. More on that in a second, but back to the Degenerate era. Keep your eyes open for rare collisions between remnants stirring things up in the universe. Like if 2 brown dwarfs collide, it might give birth to a new star that lives for trillions of years. Or if 2 white dwarfs collide, you could see a supernova explosion. But overall, the universe is becoming cooler and darker. Matter and its tiniest building blocks continue to decay. Alright, that's our 10 quintillion years. Pretty crazy, but what happens after that? What happens at the end of the universe? 10 decillion years. Okay, at 10 decillion years, that's a 1 followed by 34 zeros. You're close to the end of the Degenerate era. White dwarfs, brown dwarfs, even neutron stars will begin to die. Their death will come about because of a process called proton decay, where the tiniest subatomic particles that they're made of begin to disintegrate and die themselves. These white dwarfs will no longer be giving off an immense amount of light. Instead, they'll have the brightness of just a few light bulbs. The time it takes for this decay to be completed is incredibly long, but hey, on this journey, we've got all the time in the world. Or maybe I should say in the universe. It's sad to see these little protons die out. Well, you couldn't really see them dying because they're so tiny, but still. If the fundamental building blocks of molecules ultimately decay, it would appear that the fate of the universe is sealed. With protons disintegrating, on your last stop, you'll confront an old, unstoppable enemy. 10 duodecillion years. You're at 10 duodecillion years in the future. That's a 1 followed by 40 zeros. A lot of zeros, right? You've climbed another rung in the desolate universe. Things just keep getting bleaker and bleaker. No planets, no stars, no dwarfs. No wonder it's so dark. You can barely see anything other than a very, very weak shine. These are the black holes. It's no surprise that some scientists have labeled this time the beginning of the black hole era. Black holes are these massive structures in the universe that suck up anything that gets close to them. Not even light can escape a black hole. They're like some kind of planetary zombie, scarfing up the remnants of dead stars and getting more and more dense and massive. You thought Thanos was bad. Did I mention that nothing escapes a black hole? Yeah, well, nothing can escape a black hole. Well, there is one thing that can escape. It's been proposed that black holes might leak tiny bits of radiation. This is known as Hawking radiation. Here's how it works. Twin particles are appearing in space all the time, immediately annihilating each other, but when they appear at the mouth of a black hole, sometimes one falls into the black hole while the other escapes. Over trillions of years, this particle leakage would reduce the mass of the black hole, causing it to die. So if you did multiple stops in the time machine, you could watch these black holes eventually die out over massively long periods of time. Alright, looks like there's still some time left in the video, so let's check out what happens next. Google years and beyond. Alright, before we get to our last stop, for real this time, I gotta mention the What If Explorers Club over on Patreon. For just a couple bucks a month, you can get exclusive ad-free videos. Check it out in the description. Okay, a Google years into the future. What is that? That's a 1 followed by 100 zeros. What's happening here? Well, even the last black hole in the universe has lost its last bit of mass and died out. Welcome to the dark era. It's cold, dark, and very quiet. What can you see in our universe at this point? Well, only a few subatomic particles and dark energy. The universe has expanded so much that the few subatomic particles left are super spread out, incredibly far away from each other. At one point, there were stars, and then remnants of stars, then black holes. But now, you have to zip around in the time machine all over the area of our current universe to catch sight of a single subatomic particle. What a sad and lonely place. And remember the dark energy, the stuff that almost destroyed the universe during the Big Rip? Well, it will keep the universe expanding out further and further. And as the universe keeps expanding, it keeps cooling. Scientists have labeled this stage the Big Freeze. All energy will be evenly distributed in the universe, and the temperature will be just north of absolute zero. Yeah, very, very cold, but not as cold as winter in Canada. This theory of the universe has a cool, dark end, but there's another theory, though, called the Big Crunch. Instead of infinite expansion, the universe reaches a point where it switches into reverse and begins contracting. It would be like playing your life back to you in reverse when you got really old. You return to a baby, then to an embryo, then to a single cell. If that does play out, well, maybe then the whole cycle of the Big Bang starts up again a second time. Or maybe this has happened before and we're in the middle of one of the many cycles of expansion and contraction. Unfortunately, scientists think that's less likely. It appears more likely that the universe is in the grip of dark energy, which will lead to the Big Freeze at the end. What does this mean for the human race? Well, even putting aside the Big Freeze, things appear pretty bleak for life in the universe once we hit the degenerate era. Those damn Redditors. After all, we need bright, luminous stars to create habitable zones to live on planets. So, how do we make that a reality? Well, one intriguing possibility is the ability for us to build our own universe. Maybe in a lab. Keep in mind, we're only 200 years past the Industrial Revolution. Centuries from now, humans will know a whole lot more about how to manipulate our environment. Using our smarts will take control of the future. In fact, as humans progress from a Type 1 to a Type 7 civilization, the possibilities are mind-boggling. But that sounds like a story for another What If.
"635 light years away from Earth, there's a world covered in liquid ocean. A world where you wouldn't die a horrible death. Probably. Welcome to Kepler 22b.
Hey y'all, I've got an exciting mission to land on and explore a planet that could be Earth 2.0. What If guy got tired of sending me to die in the solar system, so this time I'm traveling to an exoplanet where I might actually have a chance to survive. Exoplanets are like planets in our solar system, except they orbit different stars. They're cool, but there's just one problem. Exoplanets are really far away. So your solar system is this tiny little neighborhood with planets and moons orbiting around a sun in its center. And potentially, light years away, there are billions of other tiny little neighborhoods.